Most JavaScript courses teach you syntax and leave you stuck the moment you try to build something real. This one is different. First, take a screenshot of this right now, because in the next few hours we start at the absolute basics, and we build all the way up to advanced JavaScript, one topic at a time. It doesn't matter if this is your first programming language ever, we start from zero. And every concept comes with practice exercises, so it doesn't just make sense today, it stays with you for years. All this course needs from you is your time. Let's get into it. So first of all, let's understand what JavaScript is. JavaScript is a high-level, dynamic programming language that adds functionality, interactivity, and dynamic updates to any website. You might have noticed one specific phrase in this definition, programming language. What is a programming language? A programming language is a formal set of rules and instructions that allows us to communicate with a computer in its own language. For example, when humans communicate with each other, they use different languages such as English, Spanish, and Pashto. Similarly, computers also have different languages. Among these, we have JavaScript. JavaScript is a language where we write code to tell the computer exactly what task it needs to perform. Let's look at an example. As you can see, I have opened VS Code, and here inside my JavaScript file, the JavaScript code is written. You don't need to understand the code right now. This is just an example. On the right side, you can see in the browser that we have two buttons. One is minus, and the other is plus. In the middle, I have a number, which is 1. Now, when I click on plus, you can see that my number keeps increasing. 1, 2, 3, 4, 5, meaning it is adding one by one. It went from 1 to 2, 2 to 3, 3 to 4, increasing this way. And when I click on minus, my number decreases. Now, how does it know that it needs to increase with this button and decrease with that one? We have specified this exact behavior inside this file. What should happen when the plus button is clicked and what should happen when the minus button is clicked. This is the magic of JavaScript. And this is exactly what we call a programming language, because a programming language is something where 2 plus 2 always equals 4. Secondly, why do we learn JavaScript? What is its importance? I would like to highlight two main points here. First, JavaScript is a programming language that serves as the backbone of modern web development and is an essential tool for software development. Second, it ranks at number 6 among the world's top programming languages in 2026. I hope you now understand its importance. In advance, I want to tell you one thing. I would highly recommend a book called A Smarter Way to Learn JavaScript. As you can see, this book is on the screen. Its link is in the description, and you can download the book from there. This book will help you master the foundations of JavaScript in a much smarter way. Plus, you are given practical exercises with every single topic, so make sure to download it. To write code, we will be using VS Code, so please download VS Code. I have already downloaded it. You can download it too. The installation is simple. Just keep clicking Next, Next, and it will be installed. We will need to create two files in VS Code, one for HTML and the other for JavaScript. For HTML, we will first create an index.html file inside the Explorer. And the second one we will create is script.js. As you know, we add an extension after the dot to specify what type of file it is. For HTML, we write .html, and for JavaScript, we write .js, as in script.js. You can also use any other name instead of script. The way to generate the HTML document structure is by using a smart shortcut, press Shift and the exclamation mark, and then hit Enter. This will give you the HTML document structure. Inside the body, we will first connect our script.js file. So we will start typing the word script. As soon as you type script, you can see that it suggests src. We will click on the third option, and inside this src, we will write the name of our file, script.js. Then we will open the script.js file. But before opening the script.js file, we will click on the Go Live icon inside the index.html file. This is an extension that allows us to see the live preview of our web page in real time, the actual output. The simple way to install this is to go to the extensions icon, click on it, and search for Live Server. I have already installed it, and you should install it too. Now we will open the script.js file, and I will shrink the screen a bit, both for VS Code and the browser outside. I am using the Firefox browser, whichever one you use is totally fine. Our very first task is to test whether our script.js file is connected to the index.html file or not. The way to test this is by using console.log, and inside it, we will type the word hello within double quotes. I will explain what console.log actually is, but before that, I will go to the browser, right-click there, click on Inspect, and after clicking Inspect, I will click on Console. As you can see, the word hello is written here. This confirms that both of our files are connected. We use the word console inside JavaScript, and we also have a console outside in the browser. So, what is a console? What can we see in a console? In this, we can see different types of data. Just like we can view data, we can also see errors here. We use it for all kinds of debugging work. When we ran a log, it means we printed a message. And we don't just print messages, we can also print variables and other things as well. So, simply put, developers use it for debugging, testing code, and inspecting data, because we obviously cannot display every piece of data directly on the web page, right? So I hope everything is clear to you up to this point, including everything I have explained. In JavaScript, the very first topic we will learn is variables in JavaScript. A variable is a container in which we store data. That data can be a number, a string, or any other data type. Now, there are three ways we can store data: var, let, and const. First, let's see what var is. Var is the original way of declaring variables in JavaScript. For example, how do we declare it and store a value? We write var, then the name, then equal to Ali inside double quotes. Now, you might be confused about why there are so many different ways. You don't need to go into depth about this right now. We will understand them one by one. The second one is let. Let was introduced in ES6. What does ES6 mean? We call this modern JavaScript because many new features were introduced to JavaScript at that time. Let is the preferred choice to use when a variable's value needs to be changed. For example, how do we store data using this? We write let score equal to 80. The 80 here is the data or value stored in the variable. What is score? Score is the name of the variable. The third way to declare a variable is const. We use const for values that should not be reassigned. How do we store a value in it? Const age equal to 25. You must have noticed one thing in all three examples. If all three, var, let, and const, are used to store data, then what is the difference between them? If they do the same job, why do we use different words? Well, you have misunderstood. It is not like that at all. The answer to this depends on two concepts: reassignability and redeclarability. Redeclaring means declaring the exact same variable name again within the same scope. With var, if you have var a equal to 5, and then you write var a equal to 10, it is allowed. The value will update to 10. The variable names are the same, and no error will occur. With let, if you have let b equal to 5, and then you try to write let b equal to 10, it will throw an error. You cannot redeclare it with the same name. With const, similarly, if you have const c equal to 5, and you try to write const c equal to 10, it will throw an error because you cannot redeclare it. So you can redeclare and reassign var. You can reassign let, but cannot redeclare it. You can neither redeclare nor reassign const. Another important question arises. In which situations should we use them? By default, we should always use const because its value cannot be reassigned, preventing accidental changes. We should only use let when we know the value will need to change. As an example, look at the counter scenario on the screen right now. Let count equal to 1. Here we used let. We could have used const, but we didn't. Why? Because this value is changing, it is not fixed. Sometimes we are adding to it, and sometimes we are subtracting from it. That's why we used let. Why didn't we use var here? In modern JavaScript, we don't use var at all. var was used before 2015. You only need to learn about var so that you know it exists as a variable type in JavaScript, but you can forget about using it practically. We won't be using it. The last yet highly important topic regarding variables is the naming rules. In JavaScript, we must follow specific rules when naming a variable. The first letter of a variable name must start with a letter, an underscore or a dollar sign. For example, let name starts with a letter. Let underscore value starts with an underscore. Let dollar price starts with a dollar sign. The name must begin with one of these three. A variable name can never start with a number. For example, let one name is incorrect and invalid. To fix this, you can write let name 1. The number can be in the middle or at the end, but never at the very beginning. Variable names can only contain letters, numbers, underscores, and dollar signs. No other special characters are allowed. You cannot include spaces inside a variable name. For example, let first name, written with a space, is invalid. A better way to write this is let first name. Notice how the first letter of the second word, N in name, is capitalized. This makes the code easier to read. You cannot use JavaScript's reserved keywords as variable names. Reserved keywords are predefined words in the language that already have a specific meaning and function, such as var, let, and const. For example, writing var let equal to 1 will throw an error because let is a reserved keyword. Other examples include function, for, if, and so on. Variable names are case-sensitive. For example, let age equal to 20 and let age with a capital A equal to 20 are treated as two completely different variables by JavaScript because one starts with a lowercase a and the other with an uppercase A. You should always use descriptive names. Instead of writing let x equal to 10, it is much better to use names like student age, is logged in, register form, or total price. When a variable name consists of two or more words, we use camel case. For example, with the words first and name, we combine them as first name, where the first word is lowercase and the first letter of the following word is capitalized. This ensures clear readability. We will understand another thing, and that is for you to look at this image. In this image, we have a box. In this box, we have 25, which is the value, and the name of this box is user age. For example, in a variable, we store data. To understand this in a real-world analogy, this is a box. What is the box for us? A variable. Now, the data that we store in a variable, here, I had stored 25, which is the age, a number, so you can see inside this box, I have 25. Just like I gave the variable the name user age, here too, we will give a name to the box, right? That name is user age. So what do we get in the end? The variable becomes our box, its name becomes user age for us, and the data we stored in that variable here in the box, we have that value, which is 25. So variables have a scenario like this in JavaScript. Let's move toward the code. So I have opened VS Code and I am in the script.js file. And on the right side, my browser is open. You know how to get to the console. Click on Inspect, and then click on Console, and it will appear. First of all, I will declare the variable, so I will write var, then I will give this variable a name, and then equal to. Then inside double quotes, I will write John, and at the end, a semicolon. We declare a variable like this. Now, the data stored in this for us is John, which is a name. Now, how will we know what is stored inside this name? To see this, we will write, so I will do console.log, and inside the log, I will write name. Just as I wrote name, you can see in the browser. One thing you must have noticed is that after every character, the browser automatically refreshes because I have turned autosave on. Just like I wrote console.log and then wrote name inside this log, you can see outside in the browser console, John has appeared. This means that the name variable we have, the data we have in it, is John, a name. Similarly, if I replace var with let and John, which we have, replace it with Umer, then you can see outside in the browser, we have Umer. So it means that we can store data in the let variable as well. Similarly, we are left with const. So I will write below const, then I will write number, and after number equal to 10. And then below, I will do console.log, write number inside the log. So you can see outside in the browser that I have got 10. This means that we can store data, numbers, values, data types in const variables as well. we learned a concept theoretically, reassignability, meaning we can give a new value to an existing variable, we can give a new value. So we said that we can give it in var and let, but we cannot give it in const. So now we will see practically in coding how this works. For example, look at the code. In our first line, it is written let name equal to Umer, and outside in the browser as well, we have Umer. But I want to change it back to John, so what will I do? Below this, I will write name equal to John. So you can see outside in the browser, I have got John. This has changed. Now inside the name variable, the data stored for us is John. It is not Umer. If I now replace let with var, even then it will remain John. You can see there is no error. Reassignability is allowed in let and var. But when I do const here, then an error will come. And what is that error? Invalid assignment to const name. And you can also see the error, our error has come on line 2. So just as I told you theoretically that const does not allow it. Why doesn't const allow it? I'll say it again. It doesn't allow it because in const you have to give a fixed value so that you don't change this value again. And we will use const. We will use let as well, but we will use it when we want to change the value. And we won't use var at all. And the example of let, I have shown you the counter 2 times. Now I cannot show you a third time how the value changes with let. We have redeclarability. This means giving the same name to variables within the same scope. For example, there are 2 variables, 3, 4, giving them the same name. So in var, this is allowed, just like in my code, where we have const name equal to Umer, I will replace const with var, and below where we have name equal to John, I will write var before name, I will just add the var keyword. So you can see outside in the browser, I have John. There is no error. There are 2 variables, same naming, no error. This is allowed in var. Redeclarability is allowed in var. But if my first variable is var name, if I replace this var with let, then you can see an error, redeclaration of let name. An uncaught syntax error has occurred. This error is saying that you cannot redeclare this let, meaning if you have a let variable, then you have to give a different name within this same scope. You cannot redeclare it with the same name. Similarly, if I do it for const as well, even then the same error will come. If similarly I do it for const as well, even then the same error will come. So here our 2 concepts are cleared. One is reassign and the second is redeclarability. Similarly, another thing I will teach you, just like we comment code in HTML or CSS, the code will remain, or some text will remain, but we just want it to stay inside VS Code and don't want to show it outside in the browser. So similarly, we can do it in JavaScript as well. You have to press Control and /. You have to press this, so however much code you have selected, that is what you can comment out, just as you can see I have done. And manually as well, if you can do it, for example, // at the beginning, then that code will get commented. Similarly, we move towards some rules. We also learned rules, variable naming rules. So for example, first I will show you I write let. Then I write one name equal to 3. Now this is giving an error. Why is it giving an error? If you hover over this, it says that an identifier or keyword cannot immediately follow a numeric literal, meaning you can use a numeric value later, you cannot use it at the start. So what will I do? I will remove the 1, and if I add 1 after name, and with name, then there is no error. Similarly, if I write first name first, and then I do, put a space, meaning keep a space, and then write name, then this will also give an error. Now, why is this giving an error? This is giving an error because space is not allowed. If you want to write this, you will write it in camel case first, and then you will write name along with first, but the first letter of name should be capital. Similarly, another important rule is, for example, I write let function equal to 12. Now this is also giving an error, and what is the error? Unexpected token keyword function. This error is because you have used JavaScript's reserved keywords. You have used them for variable naming. So JavaScript's reserved keywords, whatever they may be, you cannot use them as a variable name or a function name. So I hope you have understood this. Our second topic is data types in JavaScript. What is a data type? A data type is the type of value we store in a variable, which helps determine how that value can perform various operations. There are two main categories of data types: primitive data types, non-primitive data types. A primitive data type is one that stores a single, simple value, and its value is immutable, meaning it cannot be changed. There are 7 types of primitive data types. Number, this can be an integer or a decimal number. String, this represents text. Any text can be a string. Boolean, this represents either true or false. Undefined, this occurs when we have declared a variable but have not assigned any value to it. Null, this represents the intentional absence of any object value. We have declared a variable, but its value is explicitly empty or null. Big int, this is used for larger integers that are beyond the safe limit of the standard number type. Symbol, this is used to create unique identifiers. We won't look too deeply into symbol and big int right now, as they aren't as crucial for beginners learning data types. Non-primitive data types are used to store collections of values and more complex entities. The primary non-primitive data type is the object. An object stores data in key value pairs, meaning there is a key and it is associated with a specific value. There is another important concept. How do we find out what data type a specific value is? For this, we use an operator called typeof. The typeof operator tells us the data type of a value. For example, if we run typeof 100, the output will be number. Let's practically implement what we have learned about data types in code, so we can see the live output in the browser. I have opened VS Code and I am currently in the script.js file. First, I will write let data equal to 25. Then, underneath it, I will write console.log type of data. If you look at the browser, you can see the output is number. This tells us that the value, 25 we assigned, has a data type of number. If I remove 25 and write John instead, let data equal to John. You can see in the browser that string appears. Because John is a text value, it is considered a string. Essentially, any text will be treated as a string. Here is an important detail you must understand. What if I remove just the word John and write 25 inside those double quotes? Let data equal to 25 in string form. As you can see, the output is now string. Previously it was a number, but now it is a string. Why is that? You must keep this rule in mind. Anything you write inside double quotes or single quotes will be treated as a string by JavaScript, regardless of the actual data type of the value inside. It is processed simply as text. If I replace the value with true, let data equal to true. The browser output shows Boolean. If I change true to false, it will still output Boolean because Booleans consist of true and false values. Now, if we remove the value entirely and just write let data, if you check the output, it says undefined. Undefined means we have successfully declared the variable, but we have not assigned any value to it. Next, if I set it to null, let data equal to null. If you look at the output in the browser, it says object. Historically, there has been a bug in JavaScript where running typeof on null returns object, even though its actual logical type is null. I hope you now have a complete understanding of JavaScript data types. Our next topic in JavaScript is the operator. An operator is a special symbol used to perform a specific operation on variables or values. In JavaScript, we have many operators. The first one we will discuss is the arithmetic operator. Arithmetic operators are used to perform mathematical calculations. Normally, these include addition, subtraction, multiplication, division, and so on. The second operator we have is the assignment operator. An assignment operator is used when we update a value inside a variable or when we assign a value to a variable. These include equal to, plus, equal to, minus, equal to, and so on. The differentiation between assignment operators and arithmetic operators will become clearer to you in the code. When I write the code, I will explain the differentiation and how they are different. The third one we have is the comparison operator. Comparison operators are used when we compare two values, and as a result, we are given true or false. These include equal to, written 2 times, and when the equal sign appears 3 times, which we call strict equal. We also have not equal to, strict not equal to, greater than, less than, greater than, or equal to, and less than or equal to. These are what we have in comparison operators. The fourth one we have is the logical operator. We use logical operators when we combine or compare multiple conditions. The symbols we have for this are and, or, and not. Mostly these three are used. Fifth, we have the increment and decrement operators. These either increase or decrease the value of a variable, as you can understand from the names increment and decrement. A++ will increase the value by 1, and a minus minus will decrease it by 1. We also have the type of operator, which you have already learned about, which tells us the data type of a value. So let's move on to the code and implement this practically so you can have a better understanding. I have opened VS Code, and first, we will practice arithmetic operators. First of all, I will take a variable, let x equal to 5. Then I will log this to the console, console.log x plus 5. Here, which arithmetic operator did I use? I used the addition one where plus means addition. If you look at the output, we get 10. Why did we get 10? Because our variable already holds 5, and inside the console, we added 5 to it. So 5 plus 5 equals 10. Then we will write again, console.log x minus 5. Since I wrote x minus 5, as you can see in the browser, the output I get is 0. Why is it 0? Because when we subtract 5 from 5, nothing is left. Similarly, I will write console.log x times 5. You can see in the browser that I get 25. Why did 25 come up? Because when 5 is multiplied by 5, it results in 25. This is how arithmetic operators work. I will comment all of these out, and now we will understand assignment operators. In assignment operators, first, we will take a variable, let z equal to 5, and then we will write console.log z plus equal to 5. Now you can see in the browser we get 10. Because we added 5 to 5, we got 10. If you noticed one thing, in arithmetic operators we also got 10 for 5 plus 5, and here we also got 10 for 5 plus 5. I will explain the differentiation to you in just a minute. Next we will write console.log z minus equal to 5. If you look at the output in the browser, we get 5. You might have noticed something here. Ideally, 5 minus 5 should have been 0, but here we got 5. Why did we get 5? The output should have been 0, so why is it 5? The main reason is that arithmetic operators and assignment operators are different. Arithmetic operators perform mathematical calculations on a value, but they do not update or change our variable. It remains the same. On the other hand, assignment operators update or change the variable itself. First, we wrote console.log z plus equal to 5, so our value became 10. Now our variable let z equal to 5 no longer holds the value 5, it now holds the value 10, because it updated the original variable. So when we wrote the third line, console.log zd minus equal to 5. We got 5 because when you subtract 5 from 10, you get 5. For the third time, we will write console.log z times equal to 5. Now our output will be 25 because 5 times 5 gives us 25. Now let me explain the differentiation to you clearly. First, what I will do for the arithmetic operator above, where we have let x equal to 5 commented out, I will uncomment it. And our third console log, console.log x times 5, I will uncomment this too. Below, I will write console.log x. And for our assignment operators, what I will do is comment out the two console logs for plus equal to and minus equal to. Down here we have console.log z times equal to 5. Below this, I will write console.log z. Now you will easily understand the differentiation. In arithmetic operators, we have the value x equal to 5. In the console, we did x times 5. The first output we get is 25. Then, when we logged x to the console, the value we got was 5. You must have understood the characteristic of arithmetic operators now. They do not update the original variable. Now look below. We took let z equal to 5. Then we wrote console.log z times equal to 5. So 5 times 5 will give us 25. We got 25 in the console. Below that, we logged z. In z, we also got 25. Even though we just logged z and it should have returned 5, we got 25. This is the power of assignment operators because they update the variable. In our upper console, z times equal to 5 updated z by replacing 5 with 25. Now when we log z down here, we get 25 instead of 5. I hope you now understand the differentiation between arithmetic operators and assignment operators. The third operator we have is the comparison operator. In comparison operators, we will first write console.log 5 equal to 5. Obviously 5 is equal to 5, so our output in the browser will be true. Similarly, we will write console.log 5 equal to 5 in string form. We wrote it a second time, but this time we put the second 5 inside double quotes so that it is considered a string. You can see in the browser we get true. Why did we get true? You will find out in the third console log. For the third time, I will write console.log 5 strict equal to 5 in string form. But this time, I wrote the 5 inside double quotes with a triple equal sign. Now we get false. Why did we get false? It should be true because 5 is equal to 5, right? But we got false. In our second console log, we got true. The double equal symbol only checks the value. It checks if the values are equal, and since 5 is equal to 5, it returns true. It does not check the data type. But in our third console log, we used the triple equal symbol. This checks both the value and the data type. The main reason it returned true is because it is checking the data type. We wrote the second 5 inside double quotes. Since a number and a string cannot be equal, this statement that they are not equal is correct. That is why it returned true. Similarly, I will comment this out and write below console.log 5 greater than 5. Our output in the browser is false because 5 is not greater than 5, they are equal. Then I will write console.log 5 less than 5. The output is also false because 5 is equal to 5, it is neither greater nor smaller. For the third time, I will write console.log 5 less than or equal to 5. The output in the browser is true because even though 5 is not less than 5, 5 is equal to 5, which is why it returned true. And if I write console.log 5 greater than or equal to 5, this will also return true because 5 is equal to 5. This symbol means either greater than or equal to. Next, I will comment this out, and we will move to logical operators. In logical operators, first of all, we will write console.log true and true. The output in the browser is true. For the logical and operator, the rule is that all of our conditions must be true. If even a single condition is wrong or false, our output will be false. If I write a second time console.log true and false, we get false in the browser. I will comment this out, and below I will use the OR operator. Let me explain what OR is. For OR, if even a single condition is true, our output will be true. It will only return false if none of the conditions are true. Here I write inside the console.log true or true. We get true. Then I write console.log true or false. This also returns true because at least one of our conditions is true. Then, for the third time, I write console.log false or false. We get false because all of our conditions are false. Lastly, we have the NOT operator. The NOT operator flips true to false and false to true. If I write here console.log not false, we get true. And if I remove false and write console.log not true, the output we get is false. For practice, we have one last operator left, which is the increment and decrement operator. I will take a variable, let x equals 5, and then below I will write x plus plus. And below this, I will log x console.log x. We get 6 because the increment operator increases the value by 1. So when 1 is added to 5, we get 6. If I write x plus plus one more time below the first x plus plus, our output will be 7. Similarly, we have the decrement operator. If I take let z equal to 5, and then write z minus minus, and log z below it, console.log z. We get 4 because when 1 is subtracted from 5, we get 4. So I hope you have understood operators properly. I do not have a better way of explaining them than this. Our next topic is conditionals. A condition in JavaScript is a statement that allows our program to make decisions based on true or false conditions. In JavaScript, we have 4 types of conditional statements. Conditional statements are of 4 main types. First, we have if. Second, we have if else. Third, we have if, else if else. And the last one we have is switch. So first, let's understand if. The if statement executes a block of code only when our condition is true. The second one we have is the if-else statement. The if-else statement executes one block of code if our condition is true, or another block of code if our condition is false. Third, we have if, then else if, and then else. This is used when we need to check multiple conditions. We don't just have 1, 2, or 3 conditions. We have more than 2 or 3 conditions. And the last one we have is switch. Switch is used. It also works similarly to conditional statements like if-else, but it is a shorthand way to compare a value against multiple possible values. So I will give you some practical practice on how we use its syntax, and then you will understand it. So first in the code, I will write, let age equal to 18. For example, we have a user whose age is 18. And I will place a condition below. To write the condition, first I will use the first statement, which is if. Inside the parentheses of if, I will write age greater than or equal to 18. What is happening here is if the user's age is greater than or equal to 18, then inside this, I will write the code that you want to execute. For your understanding, I will simply write console.log you are eligible. So now obviously my user's age is equal to 18. It is not greater, but it is equal to 18. So this condition has become true. So this block of code will execute. You can see in the console, you are eligible. And if I change this, if I replace let age equal to 18 with 20, then let's see. Now what is my condition? It is still true. If I replace this age 20 with 15, now nothing will happen. The condition has become false, but nothing will happen for us. Nothing will happen because we only want to execute this code when our condition is true. Now what will we use as the second statement here? Here we will use else. Else executes code if the condition becomes false. So after if, I will write else. And inside else, I will write console.log you are not eligible. Now what does this mean? Now you can see in the browser, you are not eligible. Because our condition became false as the user's age is less than 18, we cannot allow them. So the condition that becomes false will go into our else block. If the condition is true, it will go into our if block. So I hope you have understood if else. I will comment out this code, and then below this, I will write, let marks equal to 82. Now in this, I will check a student's marks, so my marks are 82. Below, I will write an if statement. If marks are greater than or equal to 90, then inside this, I will execute this code, console.log grade A. What does this statement mean? If the marks are greater than or equal to 90, then give them grade A. After this, if this condition becomes false, which it obviously will, because our marks are 82, not 90, then below this, I will write else if. Else if here means or if. Or if the marks are greater than or equal to 80, then inside this, I will execute the code, console.log grade B. So obviously, which grade will run for me? Grade B, because my marks are 82, and the condition here is if marks are greater than or equal to 80. Since the marks are greater than 80, you can see grade B in the browser. Third, I can write, else if marks are greater than or equal to 70, then console.log grade C. And lastly, we will write else. Inside else, we will write console.log fail. Sorry to say fail, but there is no reality in this. So here you can see the conditions. Our first condition checks if marks are equal to or greater than 90, then give grade A. If the marks are equal to or greater than 80, then give grade B. If this is not the case, then if the marks are equal to or greater than 70, then give grade C. If all these conditions are false, then lastly, we will have to console.log fail. Then this condition will run, and definitely this condition will run. Now, if I have marks as 82 and if I change it to 92, then I will get grade A. If I change it to just 2, then I have failed, as you can see the value in the browser. After this, I will comment this out, and I will take the switch cases to show how switch statements work. First, I will take a variable for the day, so I will do let day equal to 3. And below, I will write switch. This is its convention. You have to follow this convention. I will write switch. Then inside the parentheses, I will write day. Then inside the curly braces after day, I will write case 1. Where we were using if before, here we will use case 1. If it is case 1, then I will console.log Monday, and after this, I will write break. Now let me explain this code to you. What does this mean? Case 1 here means that if day is 1, then this will be Monday. And then below, I use the word break. Break means to not execute the code any further and stop the code execution here. That is what break means. Once the condition is true, do not execute the code any further. Stop it immediately. Obviously, this condition has become false because our day is 3 and here it is 1, so this condition has become false. The code will execute further. Third, we will take case 2. Inside case 2, we will have console.log Tuesday, and then below it, I will put a break. So if our day is 2, it will be Tuesday. This condition is also false because our day is 3. Then below this, I will take case 3. And inside this, I will write console.log Wednesday, and then I will break. Here, this condition will be true because our case 3 matches our day 3. And what will day 3 be in the console? Wednesday. So you can see Wednesday in the browser. And I have used break. Now my code will not run further because this condition has now become true. And below this, just like we have else and if else to run a block of code if all conditions fail, we have default here. If all cases fail, then do this. Default console.log invalid day. In default, I will get invalid day. So how will this run? Now I will show you the default one. First, I will change let day equal to 3 to 5. So you can see invalid day in the browser because day 5 does not exist in my cases. So I hope you have understood all the concepts clearly. Our next topic is loops. What exactly are loops? A loop is a block of code that will continue to execute until a specific condition becomes false. There are different types of loops: the for loop, while loop, do, while loop, for in, and for of. But first, we will cover the for loop. We use a for loop when we already know how many times we need the loop to run. Next, we have the while loop. A while loop is used when we want the loop to run as long as a specific condition is true. That means it will execute while the condition remains true, but as soon as the condition becomes false, it will stop immediately. The third loop we have is the do while loop. This will always execute the block of code at least once, whether the condition is true or false. In other words, whether the condition is true or false, it doesn't matter. This code will execute at least once. It only stops when the condition becomes false. The fourth loop is the for in loop. This loop iterates through an object and checks every single key inside it. So far, I've only defined what these loops are. I'm absolutely sure that as a beginner, you might be completely confused right now because loops can be a pretty confusing topic. Once we start coding, all your confusion will go away. To start with the code, I will first show you how a for loop works. Writing a for loop begins with the keyword for. We write for, and then we add open and close parentheses. Inside these parentheses, 3 things go: initialization, condition, and update. For the initialization, we'll declare a variable using let I equal to 0, where I stands for iteration. We have now initialized I to equal 0. After this, we will set the condition. We'll write I followed by the less than symbol, and then 3. You add a semicolon to separate each part once it's complete, just like I did after finishing the initialization and now again after writing the condition. The third part is the update. For the update, I will write I++ using the plus symbol twice. Inside the curly brackets, you write the code or logic that you want to execute. Here, I'll simply write console.log I. Now that I've written this and it has run, you can see in the browser that I have 3 values, 0, 1, and 2. Let's break down exactly how this works. First, I declared the variable and set I to equal 0. The value currently stored in I is 0. Next, I wrote the condition that I must be less than 3. Since I is currently 0, the condition evaluates 2 is 0 less than 3. Obviously, 0 is less than 3, so this is true. Since it is true, the third step is the update, where we increment I by 1 using I++. Inside the curly brackets, I wrote console.log I to print the result. As you can see, the first value printed is 0. You might wonder why it didn't print 1. It's because the initial value of I was 0. Now the loop runs a second time. This is a cycle that continues to run until our condition becomes false. On the second run, the value of I is now 1, because it was incremented by I++ during the previous iteration. So I now equals 1. The loop checks, is I less than 3? In other words, is 1 less than 3? Yes, that's true, because 1 is less than 3. It increments again, and our console prints the value. You can see the value 1 has appeared because 1 is less than 3. Now I becomes 2. It checks, is I less than 3? Since 2 is less than 3, this condition is still true. I is incremented again, and when we log the result, we see 2 in the browser. Next, the value of I becomes 3 because it was incremented once more. 2 plus 1 equals 3. Now, our variable I is no longer 0 or 2, it is 3. The loop checks the condition, is I less than 3? That means, is 3 less than 3? This is false. 3 is equal to 3, not less than 3. Since the condition is now false, the loop stops executing. The update step and the code inside the block will not run again because the condition evaluated to false. If it had been true, it would have kept going. In the browser, you can see the loop stopped at 2, and 3 was not printed because the condition became false. The next loop we have is the while loop. As I mentioned earlier, a while loop runs as long as the condition is true. Here, we will declare a variable, let I equal to 0. The value inside I is currently 0. To write a while loop, we use the keyword while, followed by an open and close parentheses. Inside the parentheses, I'll write I less than 0. This is the condition. Looking at this condition, you have to ask, is I less than 0? Obviously, this is false because 0 is not less than 0, they are equal. Inside the block, you write the code you want to execute. I will write console.log I, and below that, I++. If the condition is true, the value will increment. But look at the browser. Nothing is showing. It's completely blank because the condition evaluated to false right away, so the code block didn't run at all. To make this condition true, we can replace the 0 in our condition with 5. Now look at the browser. We have the values 0, 1, 2, 3, and 4. This works as a cycle. Since I starts at 0, the loop checks the condition, is I less than 5? Since 0 is less than 5, the condition is true. It runs the first time, prints the value, and increments it. Then it checks again. This continues as long as the condition remains true, and it stops when it becomes false. On the final iteration, I becomes 5. The loop checks, is 5 less than 5? Of course not. The condition becomes false, so the loop stops. That's why the last value printed in the browser is 4 and 5 is not printed. I hope you now understand the while loop. The third loop we have is the do-while loop. Let's see how it works. To understand this, we will first write let x equal to 0. The value of x is 0. We write the keyword do, and then inside curly brackets, we put our code, console.log x. After the curly brackets, we write our condition using the keyword while followed by parentheses containing x greater than 0. What is happening here? The condition x greater than 0 is false because 0 is not greater than 0. Even though the condition is false, the code block still executed once, and we can see 0 printed in the browser. Why? This is the nature of the do-while loop. It will always run the code block at least once, regardless of whether the condition is true or false. Let's see what happens if we change the value of x to 5. Now we have x initialized to 5. The loop checks the condition, is x greater than 0? Since 5 is greater than 0, this is true. Because the condition is true and we haven't added a way to update or increment or decrement the value to eventually make the condition false, the loop will run infinitely. As you can see, within a second, our browser has crashed because the loop kept running infinitely with no stop condition. This is why you must be very careful with do-while loops. We rarely use them in this way. Now we need to close the crashed browser window, stop our live server, and start it again to open a new browser window. You should notice one thing: both loops run when the condition is true. But the main difference between a while loop and a do-while loop is this. A while loop checks the condition first and only executes the code block if the condition is true. If the condition is false from the start, the code block never runs. On the other hand, a do-while loop will execute the code block first and only then check the condition. This guarantees that the code runs at least once, even if the condition is false. That is the key difference to remember. Now we have one last loop to cover, which is the for in loop. To understand this, we will first create an object named user. We write const user equal to an object with name Alex, role developer, and age 28. Don't worry about what an object is right now. We will cover objects in detail in upcoming topics. For now, just know that an object is a way to store data using key-value pairs, which is something a standard variable cannot do. To iterate over this object, we will use a for in loop. We start with the keyword for, and inside the parentheses, we write let property in user. Here, let is the variable keyword. Property is a custom name we chose to represent each key. In is the loop keyword, and user is our object. Inside the curly brackets, we will write console.log property, and user of property. Once we save this, you can see in the browser console name Alex, role developer, age 28. As I explained in the definition, the for in loop iterates through the object's keys and retrieves their corresponding values sequentially. You might wonder what the benefit of this is. The real advantage becomes clear when you have a massive dataset. Right now, we are looking at a single, small object. But in real-world applications, you might have arrays containing thousands of objects. Iterating through them manually would require writing thousands of lines of repetitive code, whereas a for in loop can handle it all in just 2 or 3 lines. It keeps your code clean, scalable, and highly readable. While you might have grasped the concept of loops in these few minutes, you will need to practice writing them for at least 30 minutes to truly understand how they work. Just watching a video won't make you an expert until you write and execute the code yourself. Our next topic is functions. Functions are one of the most important topics in JavaScript, and they are used very frequently, so you will need to learn them in quite some depth. A function is a reusable block of code that we use to perform a specific task. In JavaScript, we have many types of functions, including regular functions, arrow functions, closures, callback functions, and many others. But at this stage, since we are learning the basics of JavaScript, we will focus solely on regular functions, which we also call normal functions. We declare a regular function using the function keyword, which allows us to perform basic tasks. In a function, we have the function keyword, a function name, and then we invoke the function. By invoking, we mean that while you have created the function, running it requires you to invoke or call it. This means a function will only run when you call or invoke it, and we do this using the function's name. Let's head over to the code to understand this clearly. First, we will write the keyword function. This is our keyword for a function. Whenever you write a function, you will use the function keyword, at least for regular functions. After this, you will give the function a name. Just like we give variables different names, we can give a function any name we want, as long as it's not a JavaScript reserved keyword. For example, we cannot name a function let or var. The naming rules for functions are similar to the naming conventions and guidelines we use for variables. We will name this function status, and after the name, we will write open and close parentheses. Next, inside open and close curly brackets, we will write console.log success. Now, our function is created, but nothing has happened yet, and nothing is showing in the browser. To run this function, we need to call or invoke it, which is always done using the function's name. So we will write status, followed by open and close parentheses. Now you can see success has appeared in the browser console. Our function has executed successfully. This is our regular function. There are other ways to write this as well. For instance, if I write const status equal to before the function keyword, and then remove the name status from after the keyword, leaving the open and close parentheses next to function with or without a space, you can see that our function still works. There are multiple ways to write them. When it comes to functions, there are two crucial concepts you need to learn: parameters and arguments. Let's understand what parameters and arguments are. A parameter is the variable name that we list in the function's definition. An argument, on the other hand, is the actual value we pass to the function when we call or invoke it. For example, I'll write function, and then I'll name our function add. Inside the open and close parentheses, I will write a, b. These variables, a and b, which are defined in the function's definition, are our parameters. Next, inside the curly brackets, we will write console.log a plus b. Now we want to perform this addition task using our function. This function will perform a specific task of adding numbers. To run it, we will call or invoke it by writing add, followed by open and close parentheses. If you look at the browser, it says NaN, which stands for not a number. This appears because we haven't passed any actual values yet. Here, we need to provide arguments. Arguments are where we pass the values. We will pass the values for our parameters a and b as 5, 5. Now look at the browser console, and you'll see we have 10. How did we get 10? It is because a plus b is being executed, which means 5 plus 5 gives us 10. Understanding how parameters and arguments work is a fundamental part of working with functions. I've only explained the basic concepts of functions for now, so we won't go too deep just yet since we are building our foundation. In upcoming topics, we will cover them in depth, including the different types, their purposes, and everything else. I hope you now have a solid understanding of how functions work. Our next topic is the array, which is the most important topic in JavaScript because the whole game revolves around arrays. Because arrays and objects, if you learn these two topics properly, you can think of it as having learned 90% of JavaScript, because other topics just connect things together. Okay, so what is an array? To put it in the simple words, an array is an object in JavaScript that stores multiple values in a single variable. And the data we have, the values that are stored in an array, are in an ordered form. They are in a sequential form, which we call an index. Every single value has its own index. This was the definition, and now I will show you how we write an array, the way to write it. So first, we will take a variable because we store data in variables, right? And then here, we will give the name colors. What is this the name of? Right now, we don't know what this is the name of. We don't know yet, but as we go forward, you will find out. Then equal to, let colors equal to, then inside square brackets, I will write inside double quotes red, then comma, then inside double quotes green, then comma, then inside double quotes blue. So this gives us let colors equal to a list containing red, green, blue. Now let is the variable and colors is the name of this array. This has string data stored inside it. Below this, I will do console.log colors. As you can see in the browser, I have got an array inside of which I have red, green, and blue. Now, I told you earlier that this stores data in an ordered sequence. You can see the index. There is a concept of index here. At index 0, I have red. At index 1, I have green. At index 2, I have blue. And its length is 3. What is the benefit of this index, meaning red is at 0, green is at 1, blue is at 2? What is the benefit of this? The benefit is that, for example, if this array had 100 color values stored in it, and for example, now I want to target a specific index, say at index 50, I have a color like white. White is at index 50. Now, when I want to delete it, I won't have to go inside the array. Deleting this is very simple. I can delete it directly using index 49. If I want to update, say at index 40, I have purple color, for example. Then I can update it, delete it, or remove it through the index. This is the benefit of the index. If you just, here I printed all the values in the array using colors. If you want to see the color value at a specific index, what will you do? Inside console.log, you will write colors, and after colors, you will write 0 inside square brackets. What does 0 mean? The first index. In arrays, there is a concept that normally, when we start counting, we start from 1 and then move forward. But in arrays, the concept is that it starts from 0. 0 is considered first, and 1 is considered second. So now that I have written 0 in colors, I have got red in the browser. If I duplicate this console, remove 0, and write 1, I have got green. Then, if I duplicate this console again and replace the 1 in colors with 2, I have got blue. So you can see, at every index, I am getting its respective color value. So this is an order, right? Now, if I currently have 3 values stored in this array, red, green, blue, and I want to add another one after blue, say white, I won't write white after blue inside this colors array. I can also update this dynamically. How will I do a dynamic update? I will write colors, and then inside square brackets, I will write 3. Now, what does 3 mean here? 3 means that my index 2 is already filled, because at 0, I have red, at 1, I have green, and at 2, I have blue. I have nothing at index 3, so my 3 comes after blue. So I will write 3, then equal to, and inside double quotes, I will write white. And then I will do console.log colors to see the result. You can see that after blue, I have got white as well. So this is how we dynamically add values to it. For example, if an array has quite a lot of values, and I want to see how many values are in there, how many indexes are there, since each index counts as one value. To find this out, I will use console.logcolors.length. I will use the length property. From length, you can see that 4 has appeared because red, green, blue, and white make 4. So our result is 4. Second, its data type, arrays are objects. Because objects, arrays, and functions all fall under non-primitive data types. And how is it an object? Because the data we store is stored in an object form. If you don't know what on earth an object is, we will cover that in the next lecture, and then you will understand. An object is like this here. The data stored in our array is in object form, like at 0, my red is coming at 1, my green is coming at 2, my blue is coming like that. We can update it. Another way, meaning if we, for example, currently I have red, green, blue, white. So if I now want the blue, which is at index 2, to be removed, and I want to add a number there instead, like 1, how will I do that? First, I will write colors, then inside square brackets 2, and then equal to, and inside string form, I will write 1. Now I will do console.log colors to see the result. As you can see, I have got red, green, 1, white. This has appeared. Why has this appeared? Because we updated it, and we updated it dynamically. It's not like we went inside the array and manually removed blue and added 1. We did it dynamically. Now, another beneficial thing about arrays is that we can store every data type in them. As you can see, I will take a variable, name it, let data equal to, and inside square brackets, I will write John in string form, then 25, then true, then null, then undefined. Now you look in the browser, and then when I do console.log data below, look in the browser, I have got John 25, true, null, undefined, meaning this allows every data type to be stored. A question arises, variables also store data, like let, const, var, so what is the difference with arrays? A variable cannot store data in an ordered form. It cannot make a collection of data. It can only store a single piece of data. It cannot store multiple data or multiple values, and it does not follow an order. An array can do all of this. These were the basics of arrays. Arrays have quite a lot of methods, but since we are learning the basics, we will cover them in the advanced section. At this stage, you just need to understand what an array is and how data is stored in it. You just need to understand this much at this stage. Our next topic is objects, and just like arrays are important, objects are also important. In JavaScript, an object collects complex data for us, and that too in key and value pairs. How it stores this data will now be clear to you in the code. First, we will create a constant called user and set it to an object where we define a name property with the string value Alice. And then we'll define the age. You need to write Alice inside double quotes and put a comma after it. If you don't put a comma, it will throw an error. This is its convention. Then you'll write the age, which we'll set to 28. And after a comma, is student set to false. Now we will log this to the console below to see the result. So we'll write user inside console.log. Now look at the browser. We have received an object. And in this object, we have the name Alice. The age is 28, and is student is false. You need to understand two things here. For objects, as I mentioned in the definition, we have keys and values. What exactly is a key? A key is simply the name of the property. Just like we used to have a variable name, and just like we have a name in a variable which then has its value, in the same way, we have a value associated with a key. That is the data. So these are the two components, a key and a value. And another important point is that whenever you write a key, it has its own rules. Just like variables have certain rules, this has rules too. You must always write this as a symbol or a string. You won't use anything other than these. Meanwhile, the value can be of any data type. Now, our output contains all the data that was inside the user object. But if you, for example, only want to see the name, we can use two methods to do that. One is dot notation, and the other is bracket notation. But we will use dot notation because it is the standard approach, and we use it most of the time. So we will write a dot and then provide the key. Which key do we want to look at? We want to see the name. So we will write name. Now look at the browser, we have received Alice, only the name is displayed. Similarly, if you want to see the age, just write age. And as you can see in the browser, the age 28 is displayed. Now, if you want to see is student, we will write is student. And looking at the browser, we have received is student as false. So if you want to retrieve a value using a key, you can do it this way as well. Just like we modified and added items in an array, we can do the exact same thing with objects. For example, if I want to add a location here, how do I do it? I will write user, then a dot, and then location, since location is our key. This is the new property I want to add, and then set it equal to New York inside double quotes. Now look at the browser. See what we have inside the object. If we log the user object to the console, New York will appear in the browser, meaning we have name Alice, age 28, is student false, and location New York. The complete object is displayed. If you only want to see the location inside the object, I will append dot location to user. So now I have the location as well. So this is how we can add new keys, properties, and values inside an object. This is the approach. While this is how I added a new property, you can also update existing ones. For example, currently our user's age is 28. So if I want to change it to 40, what will I do? I'll set user.age to 40. You will write 40 inside double quotes. And then I will write user inside console.log. Now look, we have received the age as 40. It was 28 before, but now it has been updated. We have performed a dynamic update. So updates are done in this manner within objects. Secondly, what if I want to delete is student, for example? How would you do that? I will write delete user.isStudent, and then I'll write user inside console.log. Now look at the browser, we no longer have isStudent. If I try to access isStudent directly on user to check it, it will return undefined, because isStudent no longer exists since we deleted it. So this is how you delete a property. And the second thing is that we can also add another object inside an object, which we call a nested object. To add this, right below where we wrote is student false inside our user object, I will write address. And after address, I will write a colon. Then inside curly braces, I will write city, which will set to New York, and the zip code will be 54000. And then I'll log the user to the console below. Now look at the browser. In our output, see what we have received. Name Alice, age 28, is student false. And then we have address, which is another object. If I expand this object, you will see that we have city New York in the zip code. So it is entirely possible for us to add one object inside another. You will do this when you have multiple properties under a single property, just like we have city, country, zip, and so on, under address. Another thing is that if you want to see only the keys and not their values, how we do that in the console is by writing console.log object.keys And inside the parentheses of keys, we will write user. Now look at the browser, we have received an array, and inside this array, we only have the names of the properties, the keys, which are name, age, is student, and address. Its values are not included. Just like this method for finding keys, we also have a method for retrieving values. And that method is using console.log, where we write object, then object.values, and inside values, we will pass user, since we want to look at the user object. Now look at the browser, we have received Alice, 28, false, and so on, along with the address. So now we have the values, and the keys are not visible here because we only wanted to see the values. If you want to see both, meaning the key and the value together in arrays, we can use a method for this called entries. So inside console.log, we will write object, then .entries. And inside the parentheses of entries, we will write user. Now look at the browser. We have received name Alice, age 28, and everything else together. The next object method we have is freeze. Freeze is a method where you cannot add new properties, you cannot remove existing properties, and you cannot change or modify any of the current properties. So how do we use this? It's very easy to use. We write object.freeze, and inside freeze, we will pass user since we want to apply it to the user object. After doing this, if I want to add some new properties, for example, if I want to add education, I will write user.education, set equal to matrix. Next, I want to try deleting a student to see if it allows deletion, modification, or adding new properties. So we will write delete user.isStudent, and then we will write user inside the console log below. And we will write one console log above, object.freezeUser. Now look at the browser, we have received two objects, and both are identical. The first one has all its data intact, and the second object below also contains the exact same data. Ideally, education should have been added, and isStudent should have been removed, but freeze made it so that you cannot do anything. You can neither add nor delete. So that is how the freeze method works. The other method is seal. Seal allows us to modify our existing properties, but we cannot add new properties, and we cannot remove existing properties. Just like I write, since I already have it written, I will remove object.freeze and replace it with seal. And below this, I will add user.name equal to John. Previously, the name in my object was Alice, but now I am changing it to John, and our data below will remain the same. I won't do anything below, I won't change anything else. So if you look at the browser, you can see that the name has indeed changed, but isStudent has not been removed. It was not deleted. And education was not added either. So now you understand that seal works this way. It neither adds new properties nor deletes existing properties. It simply allows modification of the existing properties. So this is where our section on objects ends. If we compare the differences between objects and arrays. An array collects our data items in an ordered sequence, and we can access them by their position using indexes. And we can use it, for example, to add a list of products. On the other hand, an object represents a single entity, and it does so using named properties. With this, we can access the data using keys. So I hope you now have a solid understanding of objects as well. We'll build a project. Well, we won't build it fully since we've only covered the basics, and it also requires advanced concepts, but we'll implement as much as the topics we've learned allow. We'll implement exactly that much. But before that, we'll learn another topic, the DOM, Document Object Model. This topic is quite lengthy, but we'll focus on the parts that are used most often, specifically those properties. What is the DOM? The DOM is an interface that gives us access to our HTML and XML documents. It lets us modify, create, and delete attributes and content within an HTML document. The way we see HTML code is not how the DOM interprets it. For example, look at this image. Here we have some HTML code. The DOM starts from the document. Its parent is the document. After that comes HTML. So in this image, you'll find two things: the HTML code itself and a structure that helps you understand the DOM. So if we look at the HTML page, the HTML code, we have an HTML tag, and inside it, we have two things. One is the head, and the other is the body. Inside the head, we have a title, and inside the body, we have a div. Inside that div, I have an h1 tag, a paragraph tag, then a ul, and then an li. Now, how does the document, the DOM, interpret this? The topmost parent in the DOM is the document, then HTML, because all of our page content actually lives inside the document. Inside HTML, there's a parent of what? The head and the body. Then inside the head, I have a title, and inside the body, I have one child, which is a div. And inside that div, I have three children, a paragraph, an h1, and a ul. And similarly, inside the ul, I have one child, which is an li. The DOM sees this as a hierarchy. There's a parent, then a child inside it, which then becomes a parent itself, and another child comes inside that. In simple terms, it converts the HTML document into an object structure. JavaScript's DOM works on this object structure rather than on the raw HTML. Looking at this HTML in the image, you might wonder, there's no document written anywhere, so how does the DOM start from the document? This entire HTML lives inside the document, because whenever we target something, we start by writing document first. In other words, the document is the root. Whenever we work with the DOM, we always start from the document. To modify, remove, or delete anything in the DOM, we first need to select it. The element, and for selection, the common methods we have are first get element by ID. For example, say we have a paragraph containing the text hello. If you've learned CSS, you already know we use IDs there. Since IDs are unique, you'll target that specific element using the getElementById method. The second method we have is getElementsByClassName. Similarly, in CSS, we also have classes, so if you need to target a class, you use getElementsByClassName. The third method we have is getElementsByTagName. Just as HTML has tags like the paragraph tag, div tag, or span, this method targets only the tags. And then we have Query Selector. Query Selector can target both IDs and classes. But with this, to target a class, you use a dot followed by the class name, and to target an ID, you use a hash symbol followed by the ID name. Similarly, we also have Query Selector All. The difference between Query Selector and Query Selector All is this. With Query Selector, if we have a parent, say a div containing 5 paragraphs, Query Selector will only target the first one. It selects just the first matching child inside the parent. Query Selector All, as the word all suggests, means that if multiple elements share the same class or ID name, it will target every single one of them. We also have a method used for changing content called text content. Text content changes our content. For example, if we have a paragraph that says hello, and you want to remove that text and replace it using JavaScript, the text content property can do that job. Similarly, we have another method called createElement. This method creates a tag, elements like a div or a button, created dynamically. The DOM has many more features, but we won't be covering all of them. Since we're still learning the basics at this stage, this is just our foundation. An important part of the DOM is event handling. This is one of the most important capabilities for handling user interaction. For example, take a click. A click means clicking on something, and say we have a button and we click on it. So how will JavaScript know the button has been clicked? For that, we use an event called click. So when you attach a click event to an element, a specific action runs whenever the user clicks it. For example, say I have a button, and I assign it like this. A constant named button equal to document.querySelector targeting the button. Here, I've targeted the button using query selector, and next, I call button.addEventListener with a click event. Here, the event I've applied through addEventListener is a click event, and inside it, I log button clicked to the console. This means that whenever someone clicks the button, that message gets printed to the console. Similarly, there are many other events such as input, change, submit, mouse over, and mouse enter. We'll learn about these later. Once we need these in the project, you'll see their real-time output, which will make everything much clearer. So, our JavaScript foundation is now covered, and after this, we'll start implementing it in the project. For the currency converter we're about to build, we'll apply everything we've learned, variables and so on, at a basic level. And once we've built this application to roughly 20% or even 10%, we'll move on to advanced topics, since we'll need to integrate an API. And for that, we'll learn async and await, along with related concepts. Those come under advanced JavaScript, but since we've already covered a good amount of theory, we'll now move on to building it into the project. We'll build this project from scratch. So first of all, you can see I'm in VS Code. And which folder am I in? I'm inside the currency folder. So here, first of all, I'll create 3 files. The very first file I'll create is index.html. Index.html is for our web page. After this, I'll create style.css. In the style.css file, we'll write the code that makes this currency converter project look good on the web, and our third file will be script.js, where all of my logic will go. In index.html, first of all, I'll generate the HTML document. Its shortcut is Shift plus the exclamation mark. I'll press Enter on this, then Enter again. You can see the document title currently says Document, but before that, I'll click on the Go Live button. This lets us see a live server, so as we develop, it gives us a live preview and we can see the output immediately. I'll adjust the screen a bit. Roughly 70% will be my VS Code and 30% my Firefox browser. Right now, nothing is visible on the screen. It's completely blank. If you look above, Document is written in the Browsers tab. Here we'll change this title to Currency Converter. Now you can see out in our Browser tab, the text Currency Converter has appeared. After this, we'll link our style.css file. So to link it, we'll write the link tag. Just as I typed the link tag and pressed Enter below the title, you can see we get the href attribute, where we'll provide the file location using a relative path, which will be style.css. Similarly, I'll also connect the JavaScript file. We'll connect it inside the body. The reason for connecting it inside the body is so that our script.js file loads at the very end. If it loaded first, the website would break within the first few seconds since it depends on the HTML being ready. And we'll place it right at the bottom of the body, because that way it runs only after everything else has already loaded. So how will we do this? We'll type script, and as soon as I type it, 3 suggestions appear, the third one being a script tag with a source attribute. I'll press Enter on that, and now you can see the script tag has been created with a source attribute already in place, where we'll add script.js. Now successfully, our JavaScript file has also been connected. First of all, we'll write the HTML code. So inside the body, I'll create a div, that's an HTML tag, and inside it, I'll create an h2 with the text currency conversion. You can see out in the browser, currency conversion has appeared. It's auto-saving for me now, so I don't need to press Ctrl+S. I've already shown you how to turn on autosave. Similarly, below the h2 tag, we'll create another div, and inside that div, we'll have a label. We'll remove the for attribute from the label, and inside it, we'll add the text you send. After this, below the label, we'll create another div, and inside that, a second div will go. And inside that second div, a third div will go. And inside that third div, I'll have 3 spans. In the first span, we'll have the dollar symbol. In the second span, I'll have USD, and in the third span, I'll have a small black downward pointing triangle symbol. After this, we'll skip past the closing div, and below it, we'll create a UL, and inside the UL, an LI will go, and inside that LI, I'll have 2 spans. Inside the first span, within the LI, we'll create another nested span. And here's something important to notice. For the LI inside the UL, we'll duplicate it 5 times using Ctrl-D, which is a shortcut I use. You can also just copy and paste it instead. After duplicating, I now have roughly 6 LIS inside the UL. LI stands for list item. Just follow along exactly the way I'm doing it. This is a shortcut technique. Since there are 6 LIS, typing the same attributes into each one manually would take much longer. So the shortcut is to hold the Alt key and click wherever I click. First, I hold down the Alt key without releasing it, and click inside the first LI, then the second, then the third, and so on through the fourth, fifth, and sixth. Now the cursor is active on all 6 LIS at once. Now inside the LI tag, I'll add a space and type data, followed by a hyphen, then value, then an equal sign, and inside the quotation marks, I'll leave it empty. And similarly, just outside those quotes, I'll type data, a hyphen, then symbol, so they stay connected, followed by an equal sign, and inside a new set of quotation marks, I'll again leave it empty. Now I'll simply release the Alt key, and wherever I click the mouse, this multi-cursor effect disappears. Now you can see with this shortcut, we've added this attribute to all 6 list items in seconds instead of typing each one manually. This is a handy HTML shortcut. This way, in the data value for the first LI, we'll have USD, then Euro for the second, PKR for the third, INR for the fourth, JPY for the fifth, and for the sixth and last one, CAD for Canadian dollars. These are the currency names, and in the data symbol, we'll add each currency's own symbol. USD gets the dollar sign, Euro gets its own symbol, PKR gets the rupee sign, and so on for each one. I want to make one important point here. It isn't necessary for you to type out this HTML code along with me. You'll get this HTML and CSS code from a GitHub link in the description. Both of these files are available there. There will also be a script.js file, but it will be empty because you should build that logic manually along with me so you get real practice. But you don't need to spend much time on the HTML and CSS. Just download them directly from GitHub and use them as they are. Similarly, since the LI contains a span, we'll fill that in as well. So for the LI, we have 2 spans, and inside the first span, there's yet another span. Inside that first span, there's a second, inner span, where we'll add the dollar symbol, and in the outer span, we'll add USD. And in the second span below it, we'll add the text US dollar. Similarly, for the second LI, we'll follow the exact same pattern. First, the first span contains another span where we'll place the symbol, and just outside it, Euro will go. We'll fill in the rest the same way. I'll do it quickly, and you should follow along the same way. I filled in all of that very quickly. After this, below the closing UL, there's a div. I'll leave that div, and below it, I'll add an input field. Inside this input, I'll set the type to number, and its ID will be amount. The value will be 100, and the minimum will be 1. Let's understand this because it's important. In the input, I've set the type as number. Why a number? Because currency values are numeric, not alphabetic text. When we're converting currency, we only work with numbers, so we set the type to number. The ID for this is amount, simply because we'll need to add functionality to it later and target it from the DOM. That's why we gave it an ID. We've set the value to 100. We chose 100 so that it appears by default whenever the page reloads, and you're free to change it if you'd like. As for the minimum, you can see in the browser that the input field already shows 100. Setting the minimum to 1 means the value can never go below 1. For example, watch as I decrease the number here. I'm clicking the down arrow to decrease it. If I type 5 directly and keep decreasing it, you'll see it won't go below 1. It dropped down from 5 to 1, but it won't go any lower than that. So that's what the minimum setting does for us. In short, the minimum means the value will never fall below 1, which is what we've set here. Below this input field, I'll add a button, and inside that button, I'll place an SVG. It functions just like an icon. You could use an actual icon here too, but I've chosen an SVG. You can see in the browser that I now have an up and down style icon. We'll use this to swap the currencies. Now we've made a small mistake. We placed the button directly below the input instead of in the right spot. To fix this, we need to move it below 2 more divs that come after the input field. So what do? We select the entire button element and press Alt plus the down arrow key twice. We'll keep pressing it until the button moves below this div, past the 2 divs underneath the input. And now it's positioned outside in the right place. There, you can see it's arrived. That's exactly how it should look. Just follow the same steps I did. Next, we'll duplicate this section. Since we can't keep typing it manually over and over, right? We'll just use the copy-paste shortcut, starting from the closing div right above the button. And if you scroll up, you'll see the H2 tag for currency conversion, and the div right below it. From there, we'll copy everything up to the div just above the button. After copying, we'll paste it right below our button. And you can see it's now appeared for me. Now we need to make a few necessary changes to it, because everything can't stay exactly the same, right? So I'll adjust it. In the label, we currently have the text you send. We'll change this to they get. That's a small change, and after that, the currency that's selected in the first panel, we'll update it too. For example, it currently shows US dollars, so we'll change it to an Indian currency. So we'll replace the US symbol, the US dollar text, and US dollars itself. We'll replace all of these with the Indian currency equivalents, just like I've done here. And this upper section, the label and everything, USD, Euro, PKR, will stay identical to the second one, with no differences at all. Any real difference will be handled through JavaScript. For this, we'll use the selected class, though we won't apply it just yet. We'll avoid adding complexity for now and simply leave it as is. We've duplicated the section, but we do need to make one change here because right where the UL closes, there's also a closing div right below it. And below that, we have an input field with type number. Since we already gave a number input elsewhere and only need it once on the website, we'll remove this one here. Just one field is needed to enter a value. Below this, we'll create a div, and inside it, we'll write the text 0.00. We'll use this div to display the resulting converted value. Then, leaving two divs below it, we'll create another div. Inside that, there will be a span, and inside the span, we'll write the text 1 USD equals 0.00 INR. Congratulations! Our HTML code is complete up to this point. There are only two things left to do, assigning IDs and assigning a class. We'll add IDs both for styling and for JavaScript. And along with the styling, we'll add roughly 5 or 6 IDs specifically for our JavaScript, so we can target these elements through the DOM. First, I won't type these IDs manually, since that would take a lot of time. I'll just copy and paste them directly. You can see I'm filling them in quickly wherever the class is needed. I've finished that, so now let me walk you through it. Among the important IDs we'll need, one is on a div where we've given the class custom-dropdown. We'll use this in JavaScript, along with another class called dropdown-list. This will also be used in JavaScript, mainly so that when we click, we can target it with query selector. Similarly, I'll add the remaining IDs quickly, so the first ID will be from -dropdown. This will be used in JavaScript. The second ID, I've already assigned that to the input field for the amount. The third ID goes on the button, which you can see is swap-btn. We'll use this so that when we click the button, the arrow icon rotates by 180 degrees. We'll build that functionality, and secondly, we'll also use it to swap the currencies. The fourth ID goes on the div below. You can see the one we've created called toDropdown. We've used that for the same purpose, and for the fifth ID, there's a div below called result_value. We'll use this to display the converted result, and lastly, we have a span ID inside the footer, as you can see. This is where we'll show the exchange rate text. I also want to point out one more important detail. We have a class called selected. Selected refers to whichever item inside our first UL carries the class selected. We've placed it on the first LI since by default USD will be the selected option. Similarly, for the second LI, we have INR, which is roughly the fourth LI inside that UL. It carries the selected class, representing Indian currency. So for the second dropdown, INR will be selected by default. Now, if you look at the browser, everything appears, but it's completely static. None of it works yet. So that wraps up our full HTML code. Next, we'll move on to style.css and script.js. After the HTML file, we'll open the style.css file and I'll simply copy and paste the code, since we won't be explaining the CSS in detail. The GitHub link is in the description where you can download all of it. After this, you can see all of our styling has been applied and is complete. But the dropdown and the real-time currency rate still don't work, because the functionality is still missing. So we'll open the script.js file. In the script.js file, our very first step is to target our HTML elements using their IDs. So we'll target the input element first. Here, we'll create a variable named const amount input. We used const to declare the variable, and amount input is its name. After this, we set it equal to a DOM method. Whenever we want to target something, we go through the document, so we'll write document.getElementById. Here, getElementById means that whatever tag or element we want to target, we're targeting it specifically by its ID. Then, inside the parentheses and double quotes, and paste it here inside the quotes. Now our input field has been successfully targeted. Similarly, we'll target the second element, the from dropdown. So we'll declare a variable const from dropdown equal to document.getElementById, since this is also identified by an ID, and we'll go into the HTML to find the ID for the first from dropdown. And here, inside the parentheses, after getElementById in double quotes, we'll write from dropdown. Similarly, we'll create a third variable, const to dropdown, equal to document.getElementById, and inside the double quotes, we'll write to dropdown, which matches our ID name. And fourth, to display the result for the converted value, we'll declare a variable named constResultDisplay, equal to document.getElementById, and inside the double quotes, we'll write the matching ID, which in our HTML is result value. So we'll copy that and paste result value inside the quotes here. Similarly, fifth, we'll declare const rate text. We'll target this using document.getElementById with the ID name rate text from our HTML. So we'll copy and paste rate text inside the quotes. Sixth, the last remaining ID is swap btn. So we'll write const swap btn equal to document.getElementById, targeting the arrow toggle button whose ID is swap btn. So we'll copy and paste that here. And with that, our task of targeting all the HTML elements comes to an end. After this, we'll create a function. We'll use the function keyword and give it a name so we can call it whenever we need to. We'll name this function setupCustomDropdown. And after the name, we'll add open and close parentheses. Inside these parentheses, we'll take two parameters. I've already explained what parameters are, so I won't repeat that. One is the dropdown itself, and the second is onChangeCallback. You'll understand exactly what these two, dropdown and onChangeCallback, do a little later. So we've set these two as our parameters. Then, inside the curly braces, we'll write const header equal to dropdown.querySelector. What does this mean? We've declared a variable named header set equal to dropdown.querySelector. QuerySelector targets a class and specifically returns only the first matching child inside a parent. So here, dropdown.querySelector means the first matching child inside the dropdown. And what will we target inside it? We'll write inside dropdown.querySelector, we'll target the class dropdownHeader. If you check the HTML, this dropdown-header class is where USD is selected by default. So to show the currently selected item, we've simply targeted the dropdown-header class using JavaScript and nothing more. Next, we'll declare a variable, constItems, equal to dropdown.querySelectorAll. Earlier, we only used querySelector, but here we're using dropdown.querySelectorAll. Here, all in querySelectorAll means it selects every single matching child, not just the first one. For example, say we have a div containing 5 span elements. If you use querySelector, it would only target the first span, but with querySelectorAll, we select every one of them. So if you go into the HTML dropdown and look at the dropdown list, we have an unordered list with the class name dropdown-list, and inside it, we have several list items. There are roughly 6 list items, and giving each one an individual class to target manually, would create far too much code, defeating the purpose of using JavaScript here. So with query selector all, we can target all 6 list items in a single line. So we wrote query selector all, and inside the parentheses in double quotes, we wrote dot dropdown dash list li. This targets every list item inside the dropdown class. After this comes another important concept. Pay close attention here since it can be a bit confusing, but it's quite significant. On the next line, we'll write dropdown.value. And what is dropdown.value? Value is a keyword used to read a stored value. I'll show you exactly what that value is shortly. Through value, we can read the text either typed by the user or already set for us. So dropdown.value means we're extracting that text value from the dropdown, and we'll set it equal to dropdown.querySelector, which again targets a class. And inside that query selector, we'll target li.selected. Inside the parentheses, we now have li.selected. What does this mean? If you check the HTML inside our unordered list, we have roughly 6 list items. Among these 6, I assigned a class to only the first list item, and that class is named selected. By default, the currency selected in the first option will be USD. That's what I've set here. We haven't built the full form yet, but once we do, you'll see USD selected by default. None of the other list items carry the selected class. Only the first one does, which is why we wrote li.selected and gave it that class name. So in script.js, this line means select the dropdown whose list item currently carries the selected class. We're not selecting everything, only the dropdown whose list item contains that selected class. Next, we'll add .dataset.value. And what is dataset.value? If you check the HTML, each list item carries a data value and a data symbol attribute, so dataset lets us extract the USD value for us here. We're using .value to extract USD here, so JavaScript can read it. So now dropdown.value will be equal to USD. Putting all of this together, dropdown.querySelector, then li.selected, then .dataset.value. What do we end up getting? We get the value USD. That's how we've extracted the USD value. On the next line, we'll add a click event listener to header. And inside the parentheses, we'll write E followed by an arrow and then curly braces. Now, what does this mean? It means we've attached an event to our header, the dropdown header, so that when the user clicks on it, the code inside the curly braces runs and you'll see exactly what that code does shortly. After this, on the first line inside the curly braces, we'll call e.stopPropagation. And what stop propagation does is this. Say the user clicks and our dropdown opens. Now to close it, whenever the user clicks anywhere else. If you look at the final result on the right side just as I opened it here, clicking outside automatically closes it. That's exactly the job stop propagation performs. In other words, clicking on the header opened it, but clicking back outside on the window closed the dropdown. To make clicking outside close it, we'll add more logic further on using a remove method to accomplish that. On the next line, we'll write document.querySelectorAll, targeting the class we find in the HTML, the custom dropdown class, which we'll copy and paste as .custom-dropdown inside the quotes. Here, we used querySelectorAll because we have 2 dropdowns for 2 currencies, and we're targeting both of them. Both of them share the same class name. Then we'll chain a dot for each method onto it. I won't explain for each in depth right now since we'll cover it properly in our advanced JavaScript topics, but for now just know it's a loop that runs on every dropdown, covering both our from and to dropdowns. So inside the for each parentheses, we'll pass a parameter named d followed by an arrow, and inside the curly braces we'll write a condition using an if statement. And inside that if statement we'll write if d is not equal to dropdown, then remove the active class from it using d.classlist.remove, passing in active. This condition means that if d is not the current dropdown, we remove the active class from it. The term ClassList here is what lets us check and manage classes. In other words, it's specifically used for working with classes. Now, what is this active class? If you open the style.css file and scroll down, you'll see on the custom dropdown selector, we've added an active state. For example, by default, we have that active styling defined. So the logic here works so that when you click one dropdown and then click another, the first one's active state gets removed, exactly as we just did. In other words, if a dropdown isn't the one selected, we close it. So if there are two dropdowns and you open the first, then click the second. Both won't stay open at once. The old one closes while the new one stays open. To make both dropdowns behave this way below the if statement, we'll write, specifically right below document.query selector all will write dropdown.classlist.toggle, passing in active. This means toggle will remove the active class if it's already present and add it if it isn't. On the next line below, we have items.forEach, meaning the items here are our list items, or LIS. We'll have roughly 12 list items in total for all the currencies. We use the forEach method so it loops through every single list item, since writing one separately for each would be impractical. Inside forEach, we'll pass item as our parameter, followed by an arrow function. Inside the curly braces, we'll work with item. On item, I'll add a click event listener. Inside the arrow function, whenever someone clicks, two things get called, starting with update dropdown selection. Inside that call, we'll pass in dropdown and item. Now, what does this mean? Update dropdown selection is a function. I haven't created it yet, but I'll build it below to define exactly what it does, which is to update the dropdown. What exactly will it update in the dropdown? Here, we've passed two arguments into update dropdown selection, the dropdown itself and the item. The dropdown holds our current value, and the item is whatever the user selected. For example, USD, PKR, and so on. And right below this, we'll call the onChange callback. What exactly is this onChange callback? It updates our value. For example, later on, we'll create a function called calculateConversion. So the incoming currency values will be updated, meaning exchanged immediately. Up to this point, all the logic and functionality for our setup custom dropdown function is complete. And if you click on USD or INR in the browser on the right, none of it will work just yet, because our logic isn't finished yet. Next, we'll create another function called update dropdown selection. And its parameters will take two things, the dropdown and the target list item. Inside this function, we'll select the li.selected element using dropdown.querySelector. This is the exact same code and logic we used earlier in setup custom dropdown. There's no need to re-explain it. It selects the list item that's currently marked as selected, which by default is USD. So we'll chain on the classlist.remove method, passing in selected. This removes the selected class from USD. Then, on the next line, we call targetListItem.classlist.add, passing in selected. This simply means that if USD was previously selected, it gets deselected, and whichever item you click, say Euro or PKR, becomes the new selected item. Whatever list item you click, ClassList will add the selected class onto it. On the next line, we'll take dropdown.querySelector and target the selected symbol class. If you check the HTML inside the dropdown header, there's a span named selected symbol. It holds the currency symbol, USD, PKR, Euro, and so on. And on that, we'll apply the .text content property. This sets the text content equal to targetListItem.dataset.symbol. For example, if USD is selected, it returns the USD symbol for us, meaning the USD symbol will now appear inside that HTML span tag. Next, on the following line, we'll do dropdown.querySelector, targeting the selected text class. If you check the HTML right below selected symbol, there's a span with the class name selected text. By default, one shows USD while the other shows INR. On this, we'll apply the DOM's text content property, setting it equal to targetListItem.dataset.value. For example, if USD is selected by default and I click PKR instead, the selected text updates to PKR. That's exactly what happens, because it reads the value stored in this text. On the next line, we take dropdown.value and set it equal to targetListItem.dataset.value. This means that if the selected value becomes pkr, dropdown.value now becomes pkr, matching from dropdown.value. On the next line, we'll call dropdown.classlist.remove, passing in active. For example, when we change the selected currency from USD to PKR, as soon as a selection is made, we need the dropdown to close. So after choosing a currency, the dropdown closes automatically. This is how we'll build that default behavior. Below this, we'll add a click event listener using window.addEventListener. We'll use an arrow function, since window represents the entire browser, including everything visible on the page. Anywhere means clicking anywhere on the page at all, since window covers the whole thing. So inside it, we'll call document.querySelectorAll, targeting the custom dropdown class. And we'll chain the forEach method onto it, passing d as the parameter. Followed by an arrow function, then d.classlist.remove, passing in active. This means we've added an event on the window so that clicking anywhere closes every open dropdown. In short, clicking anywhere outside the dropdown menu closes all of them. Up to this point, the logic for our update dropdown selection function is complete. Below this function, we'll call setupCustomDropdown, and inside it, we'll pass in from dropdown. Now, if you click on the currency under USend in the browser, USD is selected by default. When I click on it now, it opens up, and when it's open, clicking outside closes it. Clicking anywhere else will also close it, thanks to that window listener. Now, when I click on it and select PKR, you can see everything updates. For example, our symbol has updated to the rupee sign. The text has changed from USD to PKR. That's exactly how the update happens. Now let's click on the bottom currency under They Get. For example, INR is selected by default, but it isn't working yet. Clicking on it doesn't open the dropdown. Why isn't it opening? Because we haven't called the function for it yet. So how do we fix that? We'll write setupCustomDropdown again below, this time passing in to dropdown. From dropdown refers to the upper one, currently showing PKR. To dropdown refers to the lower one, currently showing INR. So now if I click on the Indian currency, it opens as well. You can see it now opens and updates properly. For example, selecting Euro updates it to Euro. Whichever one you select, it opens correctly. At this point, this logic will likely seem complex, and as a beginner, that's completely fair because it genuinely is fairly advanced. Right now, our swap button doesn't work, the currencies don't swap, and the real-time exchange rate data isn't being fetched or updated. We'll handle all of that later through API calls once we learn advanced JavaScript topics, since it requires those concepts. For now, building it up to this point is enough. We'll keep refining it further as we move ahead. Once we've learned more advanced concepts like asynchronous programming and async functions and so on, we've covered the basics, which formed our JavaScript foundation, and now we'll move on to the advanced topics that make up modern JavaScript. Our first topic here is variable scoping. So what exactly is it? It determines where our variables can be accessed within a program. In other words, it defines variable visibility, showing us where a variable remains accessible. There are 3 types of variable scoping. First, global scope, second, function scope, and third, block scope. Global scope occurs when we declare a variable outside of any function or block. This means that variable can be accessed from anywhere. We'll see this shortly in the code. Second, we have function scope. Function scope occurs when we declare a variable inside a function, and it exists only within that function, allowing access only there. We'll look at some function code shortly so you can understand this better. Third, we have block scope. Block scope refers to anything declared inside curly braces. So first, let's understand global scope through code. If I declare a variable using letName equal to John, and then below that create a function I'll call scope, inside this function I'll log the name to the console. Then outside, I'll call or invoke the function. So you can see in the browser that we get John. Now when I log the name again below, outside the function, you can see in the browser that we get John a second time. So global scope means that no matter where you declare the variable, whether outside or inside a function, it can be accessed from anywhere. That means we can access it inside a function, and we can also access it inside a block because our variable was declared outside both the function and the block. That's why we're able to access it. Second, we have function scope. Here, we'll create a function named scope, and inside it, we'll declare a variable called course using let course equal to JavaScript, then log course to the console from inside the function itself. So you can see when I call scope below, invoking the function, we get JavaScript. So far, so good. But when I try to log course again outside the function, we get an uncaught reference error stating that course is not defined. This is function scope in action. It means the variable declared inside a function can only be accessed within that function. You can't access it from outside. This holds true whether you use var, let, or const. Third, we have block scope. Block scope means that anything we declare inside curly braces belongs to that block. For example, let's take an if statement. If the condition is true, we set let allow equal to welcome and log allow to the console. So you can see we get welcome in the browser. However, when I try to log allow again outside the curly braces, we get the same kind of error, an uncaught reference error stating that allow is not defined. This shows that you can access it inside the curly braces since its visibility is limited to that scope, but not outside it. If I remove let here and use var instead, you can see we still get welcome. Now, the rule of block scope breaks down here because block scope means that anything declared inside curly braces shouldn't be accessible outside, yet here it is. That's because var doesn't respect block scope. Even when declared inside a block, var ignores that boundary. Two more concepts come up here, reassigning and redeclaring, but since we already covered those under variables, we won't go over them again. Our next topic is closures. Closures are one of the more confusing topics in JavaScript. So what does it actually mean? In simple terms, a closure is a function defined inside another function, where the inner function remembers and can access the variables of the outer function, even after that outer function has finished running. Put simply, the inner function accesses the outer function scope and retains that value even after execution completes. This is what we call a closure. Let's look at the code. I'll create a function using the function keyword, naming it createCounter. Inside this function, I'll declare a variable, letCount equal to 0. We used let instead of const here since the value will keep changing from 0. Then, below that, we'll return a function. And inside this returned function, we'll increment count by 1. And below that, I'll log count to the console. Then, outside createCounter, I'll write constCounter equal to createCounter, invoking the outer function. When I now call counter, you can see in the browser that we get the value 1. Calling counter a second time gives us 2, and calling it a third time gives us 3, as you can see in the browser. Now let's break this down step by step. As soon as I called counter, count was created with an initial value of 0. Then, inside the inner function, we increment the count value and log it to the console. However, at this point, our createCounter function has already finished executing, yet the inner function still remembers the outer function scope. Below, we created the counter variable by calling the outer function, and then we invoke it separately. This means count acts as a private counter, and each call returns the inner function to us, updating the count value stored inside it. And in our code elsewhere, we can neither access nor modify that value directly. The practical use of closures is data privacy, since they hide variable data from outside access. For example, as you can see, this inner function's private data can't be reached directly from outside. This keeps it private and secure. Our next topic is arrow functions. An arrow function lets us write functions using a shorter syntax, but it behaves differently from a regular function. For example, here I write const greet equal to, then empty parentheses followed by an arrow, and inside curly braces I log hello to the console. This is the syntax for an arrow function. Now, when I call it by writing greet followed by parentheses, this invokes the function, and you can see hello appear in the browser. The name of this arrow function is greet. We created this function without using the function keyword at all. This is one way to write it. Another approach lets us add parameters as well. For example, let's write another arrow function, const add equal to, with parameters a and b in parentheses, followed by an arrow, and inside curly braces, we write return a plus b. Now I'll log this to the console. Inside the console log, I call add and pass in the arguments, the first value being 2, then a comma followed by 3 as the second value. Now, looking at the browser, we get 5 since 2 plus 3 equals 5. If I remove the return keyword here, we get undefined instead. That's because the function no longer knows what to output. Since it's defined here, you must always use return when using curly braces. If you'd rather avoid the return keyword altogether and still get the value, here's how. We remove the return keyword, then remove the curly braces too and bring a plus b onto the same line. So now the structure looks like this. Const add equal to a and b in parentheses, followed by an arrow, then a plus b. And below we've logged the result to the console. Now you can see we still get 5. This is a much shorter syntax, exactly as defined earlier compared to a regular function. We've built an entire function in a single line. This is what we call an arrow function. An arrow function behaves differently from a regular function in several ways. For instance, regular functions have access to this, while arrow functions do not. Regular functions have an arguments object, whereas arrow functions don't. You can use regular functions as constructors, but not arrow functions. Similarly, prototypes and callbacks behave differently between the two as well. There are several more differences, and I've mentioned a few, like constructors, this keyword, and the new keyword. These are all new concepts, which we'll explore in upcoming topics. That's not our focus right now. These topics can get fairly confusing, and this keyword in particular is one of the most confusing concepts in JavaScript. I hope you now have a solid understanding of arrow functions. Our next topic is default parameters. Default parameters let us assign a default value to a function parameter whenever that value is missing or undefined. For example, in the code, I write a function named greet with name as its parameter. Inside this function, I log hello followed by a comma and then name to the console. Then below, I invoke this function by calling greet. Now, if you look at the output, we get hello followed by undefined in the console. This is exactly the situation where default parameters come in handy. Right now, we haven't provided a value for name. If we want to provide one, we can pass John into greet. Now, looking at the output, hello John appears. That's when we've supplied a value ourselves. But quite often, a value isn't provided at all, so what do we do in that case? In such situations, we assign a fallback value in advance so our website doesn't break, or throw an error down the line, and here's how we do that. After the name parameter, we add an equals sign followed by John in quotes. Now, when greet is called without any argument, we still get hello John. Even though we haven't passed a value, the function still runs successfully. If we pass Ali as the argument in greet, we get hello Ali instead. But in the exceptional case where no value is passed at all, we still get John as the name. This is what we call a default parameter, and this only kicks in when the value is undefined. Undefined simply means that no value was provided. Our next topic is REST parameters. A REST parameter collects multiple arguments into a single array. For instance, we'll create a function named add, and in its parameters, we write 3 dots followed by nums. Inside the function, we log nums to the console. Then outside, we call add and pass in the arguments 1, 2, 3, and 4. Now, if you look at the browser, we get an array containing the numbers 1, 2, 3, and 4. The benefit of a REST parameter is that it gathers values for us, packing them neatly into a single array. Without a REST parameter, we could only handle a couple of values through fixed parameters, but what if we had 20 numbers to pass in? That's exactly where REST parameters come in useful. Our next topic is the spread operator. The spread operator lets us expand elements from an array or string, and it also lets us pull individual properties out of an object. For example, I write const nums equal to an array containing 1, 2, 3, 4, and 5. After this, I log to the console, using 3 dots followed by nums. Now, if you look at the browser, we get 1, 2, 3, 4, 5 listed individually. It iterated over the array and gave us each item on its own. Similarly, if we want to expand the properties of an object, we take an object, const user, with name set to Ali and age set to 20. Then below, we make a copy of it. Const copy equal to, using 3 dots followed by user inside curly braces. And below that, we log copy to the console. Now you can see we get an object containing name Ali and age 20. It gave us a brand new object. The difference between the spread operator and rest parameters is that rest collects values while spread expands them. We also use rest in function parameters while spread is used with arrays and objects and within function calls. With rest, we create a new array, while spread breaks items down individually and simply iterates through them. So that's the key difference between the two. Our next topic is template literals. Template literals are strings written using backticks instead of single or double quotes, making it much easier to build strings, expressions, and multi-line content. We'll understand this better through code, so first we take a variable, const name equal to John, followed by const age equal to 25. Then below, we log this to the console. Inside the console log, we first write my name is in double quotes. Outside the quotes, we add a comma, then write name without quotes. After name, we add another comma, then write and I am in double quotes. Outside those quotes, we add a comma, write age, then another comma followed by years old in double quotes. Now in the browser, we see my name is John and I am 25 years old. Good, but notice how many double quotes and commas appear here. It's quite messy and hard to manage. If you tried writing everything inside one set of double quotes without commas, we wouldn't get dynamic values for name and age, since anything inside quotes is treated as plain text. So to solve this problem, we turn to template literals. Here's how we solve it using template literals. We'll comment out the console log above, and below it, write a new one using backticks, starting with my name is. Then we add a $sign followed by curly braces, and inside those braces, we place whatever is dynamic for us, in this case, name. After that, outside the curly braces, we add and I am, followed by another $sign and curly braces containing age. After age outside the curly braces, we add years old. Looking at the browser, we again see, my name is John, and I am 25 years old. By now, you can clearly see how much simpler this approach is compared to the earlier one. Our next topic is destructuring. Destructuring is a syntax that lets us pull values out of an array or properties out of an object into separate variables in a clean, concise way without accessing each value individually. Let's walk through this in code. First, we take a variable, const numbers equal to an array containing 1, 2, 3, 4, and 5. Now, without destructuring, how would we access these values one by one? We'd do it like this, const1 equal to numbers at index 0. So the first number is accessed using index 0. Similarly, to access 2, 3, 4, and 5, we'd need separate variables for each, so let's quickly declare them, like const 2 equal to numbers at index 1, and so on for the rest. Now, if we want to see this in the console, we simply log the variables 1, 2, 3, 4, and 5. So looking at the browser, we get 1, 2, 3, 4, 5 listed individually, rather than as an array. Now notice, we achieved this using roughly 6 lines of code. Can we get the same result in a single line? Since we had to declare 5 separate variables and repeatedly access numbers using square brackets for each index, we absolutely can achieve this in a single line. Here's how. We write const. Then inside square brackets, we list first, second, third, fourth, and fifth, followed by equals numbers. Now we log everything we've obtained, first, second, third, fourth, and fifth, to the console. Looking at the browser, we get the exact same result, but this time in a single concise line instead of 5. There are a few important things to understand here. Just as we assigned index 0 to 1 so it accesses the first number, and index 1 to 2 so it accesses the second number, indexing starts from 0. And the same logic applies below in destructuring. First corresponds to index 0 and second corresponds to index 1. For example, if we wanted to skip the number 4, how would we do it? Since fourth comes right after third, we simply remove fourth and remove it from the console log as well. Now in the console, we get 1, 2, 3, 5, having skipped 4 entirely. That's because after third, we just left an empty comma in its place. Another situation can come up. Right now, we only have 5 numbers in this array, 1, 2, 3, 4, and 5. But if we had 100 numbers, listing them individually wouldn't be practical. The simpler approach is this. We'll remove the extra variable names like second, third, and fifth, and keep only first, then add others in their place. How do we write others? We use 3 dots, followed by the word others, and in the console log, we keep first, skip the removed variables, and add others in their place. Now we get 1 followed by an array containing 2, 3, 4, and 5. That's because we use the spread syntax on others, extracting the remaining values into their own array. We can apply the same idea to objects. For example, we'll take an object called user with name set to Ali and age set to 22. Below that, we declare 2 separate variables, one for name and one for age, since we need to access them individually. Here's how: const name equal to user.name and const age equal to user.age. Then I log name and age to the console. Now looking at the output, we get Ali, 22. If, for instance, this object contained around 100 lines of user data, or if instead of a user object we had a product listing with hundreds of fields, declaring a separate variable for every single one wouldn't be feasible. In that case, here's what we do. We write const, first removing the 2 separate variables name and age. In their place, we write const, then inside curly braces list name and age, followed by equals user. Then below, we log name and age to the console again. Looking at the output, we still get Ali, 22. What we've pulled out here, name and age, are the object's properties. And when destructuring an object, you always have to use the exact same property name as defined in the object. If you use a different name, it will throw an error. However, you can still rename it, just not directly. If you want to rename it, for example, calling name, something like full name, you'd write name followed by a colon and full name. And if you want to rename age to user age, you'd write age followed by a colon and user age. Now in the console, we remove name and age and instead write full name and user age. Looking at the output, we still get Ali, 22. So this is how we can rename properties during destructuring. I hope destructuring makes complete sense now. Our next topic is the ternary operator. The ternary operator is a shorthand way of writing an if-else statement. And in JavaScript, it's the only operator that works with 3 operands. Those 3 parts are, first, a condition, which evaluates to either true or false. Second, a question mark, meaning what happens if the condition is true. And third, a colon, meaning what happens otherwise, if it's false. You'll understand this better through code, so first I write let age equal to 18. For example, our age here is 18. Below that, we'll write an if-else statement first, so I can compare it with the ternary operator afterward. You might wonder, since both check conditions, what's the actual difference between them, and why use different syntax for the same task? You'll see this clearly once I show both versions, starting with if-else, followed by the ternary version. So I write, if age is greater than or equal to 18, then log allowed to the console. Otherwise, in the else block, log not allowed. If age equals 18 or is greater, we allow it. Otherwise, we don't. As you can see, age isn't greater than 18, but it is equal to 18, so we get allowed. Notice that writing this simple check using if-else took us roughly 4 to 5 lines. Now let's rewrite it using the ternary operator. First, we'll comment out the if-else block above, and below it write const check age equal to age greater than or equal to 18. We named this variable check age since we're checking whether age is 18 or greater. After this, we add a question mark, meaning that if this condition holds true, the code that follows will run. So inside double quotes, we write allowed. Then outside the quotes, we add a colon, meaning that if the condition turns out false instead, we write not allowed inside double quotes. To see the result, we log check age to the console. Now, looking at the browser, what do we get? Allowed. Because our age is exactly 18. It's not greater, but equal to 18, so the allowed branch runs. Notice how we achieved the exact same logic in a single line using just one variable. Compare that to the if-else version above, which took roughly 4 to 5 lines. This is the real advantage of the ternary operator. It comes from ES6, part of modern JavaScript, giving us this kind of expressive power. That's its real strength. Now you might wonder, when should we use if-else? And when should we reach for the ternary operator instead? Use the ternary operator when the condition is simple, meaning if there are multiple conditions involved, avoid using it there. It's best suited for simple situations. As a real-world example, we often use it for themes, such as if is dark is true, apply a black theme, otherwise apply white. We commonly use it for such light and dark theme toggles on websites, and similarly for login authentication, such as if logged in, do one thing, otherwise do another. Second, if we're dealing with a complex condition, meaning multiple conditions need to be checked, like grading student marks using an if-else-if chain, let's take a variable here. Let score equal to 80. Now our score is 80. Below that, we take another variable, const check score, and evaluate the score. If score is greater than or equal to 90, we assign grade A. Then we add a colon. If score is greater than or equal to 80, we assign grade B. Then another colon. If score is greater than or equal to 70, we assign grade C. Then one more colon, otherwise we assign fail. Now we log check score to the console. Looking at the browser, what do we get? Grade B. So we can also handle multiple conditions this way. I hope the ternary operator is now clear to you. Our next topic is enhanced object literals. This is also an ES6 feature in modern JavaScript, introduced because creating objects used to involve a lot of repetition. Enhanced object literals made object creation much simpler and more expressive. It's especially useful when the variable name matches the object's property name, letting us write it just once. For example, I take letName equal to John, declaring a variable where name is John. Then I take another variable for age, let age equal to 25. Now, when assigning these as properties in an object, I write const user with name:name and age:'age. Here we've defined that our object's name property is name and its age property is age. Notice the repetition here. We wrote name twice and age twice, and if we had more user details, this repetition would only grow. That's not ideal since it adds up quickly. In 100 lines of data, we'd end up writing 200 lines due to this repetition. We can achieve the same result using enhanced object literals instead. Here's how. First, we comment out this code so we can redeclare variables with the same names again. Then we write const user with just name and age inside curly braces. Below that, I log user to the console to display it. Looking at the browser, we get name John and age 25. Now compare this single line to the 3 or 4 lines we wrote earlier. Which one is simpler? Clearly, the one below. Similarly, if an object contains a function, we can simplify that as well. Here's the older way. We take an object, const obj, with a greet property assigned to a function that logs hello to the console. Then, outside, we invoke it by calling obj.greet. Looking at the browser, we get hello. But we can achieve the exact same result without using the function keyword at all. It behaves identically to what we have now. So below we'll comment out the earlier version and write const obj with a greet method defined directly using parentheses. Now greet has parentheses attached to it directly. This behaves just like a function, and inside it we log hello to the console. We get the exact same hello as before. Now compare both versions, the one above and the one below. You'll clearly find the version below simpler, more readable, and easier to work with. I hope this makes sense to you. Our next topic, as mentioned earlier, is arrays. Arrays and objects are both important, but arrays are especially critical in JavaScript and get used constantly. In the basics section, we only covered the definition of arrays along with simple examples, use cases, and basic modification and updates. We only scratched the surface there, but now we'll dive much deeper into array methods. There are many array methods available, but we'll focus on the ones used most frequently. And once you master these methods properly, you can consider yourself roughly 90% proficient in JavaScript because you'll be relying on them constantly in nearly every line of code. So, what exactly are array methods? Array methods make it easy for us to add, remove, search, transform, and process data effortlessly. They're essentially built-in functions that belong to arrays. Generally speaking, there are two categories of array methods. One category is mutating methods, and the other is non-mutating methods. In simple terms, a mutating method changes our original array. A mutating method modifies the original array directly, whereas a non-mutating method leaves it untouched. So, mutating methods change our original array, while non-mutating methods don't touch it at all. Instead, they return a brand new array to us. Let's now go through the code and see, practically and visually, which methods mutate the original array and which ones don't. First, we'll write const colors equal to an array using square brackets containing red and green. Then below, I'll log colors to the console. Looking at the output, we get red and green in the array. The first method we'll use is push. So, what exactly is the push method? The push method is an array method that adds one or more elements to the end of the array. Here's how. I write colors.push, and inside the parentheses, I add blue. We want to add the blue element, the blue value. I've already logged this above using console log. Looking at the browser now, we get red, green, blue. Just as the definition explains, it adds one or more elements to the end of the array, so naturally, blue was added right after green. If I want to add another element, like white, we get white added as well. As you can see, it can add a single value or multiple values at once. For now, I'll remove white since it isn't needed here. That was just to demonstrate that multiple values can be added. Now, the length of our array is 3. And whether this mutates the array or not, this is a mutating method, since it changes the original array directly. As you can see, the original array itself now contains red, green, blue. The second method we have is pop. Pop removes the last element from our array. Just as I wrote push above, I write colors.pop along with its parentheses. As you can see, blue has been removed from the array. This also mutates the original array. It makes the change directly and doesn't return a new array to us. The third method we have is unshift. Unshift is the method that adds an element to the very beginning of the array. As shown here, below pop I write colors.unshift, and inside it I pass 1. Looking at the browser, we now get 1, red, green. As you can see, we've achieved this result. It added 1 right before red with the help of the unshift method. And this also modifies the original array directly. The fourth method we have is shift. Shift simply removes the first element from the array. As I write below unshift, colors.shift, along with its parentheses. As you can see, it has removed one. So, to summarize these 4 methods, push adds an element to the end of the array. Pop removes the last element. Unshift adds an element to the beginning. And shift removes the first element of the array. All 4 of these fall under mutating methods. They modify the original array directly, as you've seen. Each one has changed our colors array. The fifth method we have is for each. For each loops through every single element in the array. Since arrays have indexes, it loops over each one in turn. For example, I take a variable, let numbers equal to an array containing 1, 2, and 3. Then below, I apply the for each method directly on numbers. Inside the parentheses, I write num followed by an arrow, and inside curly braces, log num to the console. Looking at the browser, we get 1, 2, 3. This is exactly how it loops through every single index. Our next array method is map. Map returns a brand new array by transforming each of its elements, and it does not modify the original array. First, we take a variable, let nums equal to an array containing 1, 2, and 3. This array is now stored in nums. Below that, we take another variable, let doubled equal to. Then we write nums, and since we're targeting this array, we apply the map method on it. Inside map, we write num followed by an arrow, and then num multiplied by 2. Now looking at the browser, we get a new array containing 2, 4, and 6. That's because each value was multiplied, iterating over every element in the array. I've also logged double to the console, so make sure to check that output as well. Now, if I log nums below, we still get 1, 2, 3. This means doubled returned a brand new array, while our original array remained completely unchanged. This is how map works for us. In real-world scenarios, when working with an array of objects, we often use map to extract specific data, such as product names, images, prices, or descriptions. Through the map method, we can easily pull out the data we need from an array. The next array method we have is filter. Filter returns a new array containing only the elements that meet a specified condition, and it does not modify our original array. For example, I take a variable, let nums equal to an array containing 10, 20, 30, and 40. Then below, I take another variable, const output equal to. Then I write nums and apply the filter method on it. Inside filter, we write num followed by an arrow, and the condition num greater than 20. Now below, I log output to the console. Looking at the browser, we get a new array containing 30 and 40. Here's what the filter method actually does. We define the logic to filter out anything greater than 20. So in our original array, the values greater than 20 happen to be 30 and 40. That's why we get 30 and 40 in the browser. This means filter only keeps the elements that satisfy the condition we've set. In this case, only 30 and 40 pass the test, since they're greater than 20. Now if I log nums again, we still get 10, 20, 30, 40. That's because it never modified the original array. It remains completely unchanged. The next array method we have is reduce, which is fairly complex and can be a bit confusing at first. You might not fully grasp it the first time around. So for now, just skim through the concept. Later, as you practice more JavaScript and apply it in real projects, understanding will come naturally. The reduce method takes every element of an array and reduces them down to a single value. It's commonly used for counting, summing, or calculating products across an array, and it does not modify or mutate the original array. For example, I'll write a simple bit of logic here. I take a variable, let nums equal to an array containing 1, 2, 3, and 4. Then below, I take another variable, let sum equal to nums.reduce. Here, I've applied the array's reduce method. Inside the outer parentheses, I add a second set of parentheses containing total and num. That's because reduce takes two arguments, a callback function and an initial value. Within the callback, there's an accumulator, the current value, the current index, and the array itself. I won't overcomplicate things here. After total and num, I add an arrow followed by total plus num, and at the end, I pass in 0 as the starting value. Below that, I log sum to the console. Now looking at the browser, we get 10. Let's see how 10 came about. 1 plus 2 gives 3, then 3 plus 3 gives 6, and finally 6 plus 4 gives 10. So the final output we get is 10, and when I duplicate this console log, replacing sum with nums, we still get the original array, 1, 2, 3, 4. It never touched or modified the original array. If this feels a bit confusing, which is completely understandable, we won't dive too deep right now, but I'd recommend checking out MDN for more detail. There, this method is explained thoroughly, so you'll gain a much clearer understanding of reduce. The next array method we have is index_of. This returns the first index at which a given element appears. In other words, if we want to locate an element's position, this tells us its index, and it does not modify the original array. For example, I take a variable, let colors equal to an array containing red, green, and blue. Then below, inside the console log, I write colors.indexOf, passing in blue. Looking at the output, we get 2. That's because, counting through the array, red sits at index 0, green at index 1, and blue at index 2. So when we searched for blue, it correctly told us its index is 2. If I remove blue and just leave empty quotes instead, the browser gives us -1. -1 simply means the element wasn't found. Even if I search for white, it still returns -1. Whenever an element isn't present, index_of returns -1, indicating it wasn't found. Then below, if I log colors, we get red, green, blue, the same original array. It never changes the original array. The next array method we have is includes. Includes checks whether a particular element exists in the array or not. and its result comes back as either true or false. For example, here I take a variable, let nums equal to an array containing 1, 2, 3, and red. Looking at the browser, there's nothing yet. Below I write console log nums.includes. Inside includes, I pass in red, and we get true in the browser. That's because red does exist in the array. If I pass in white instead, we get false, because white isn't present. And below, if I log nums, we get the original array back, unchanged. It never modifies the original array. Our next array method is find. Find is a method that returns the first matching element within an array, and it does not modify the original array. For example, I take a variable, let number equal to an array containing 1, 2, and 3. Then below, I take another variable, let check. I set it equal to number, then apply the find method on it. Inside find, we write num followed by an arrow, then a strict equality check against 2. Below, I log check to the console. Looking at the browser, we get 2. As you can see, find works by checking if num strictly equals 2, and since 2 is indeed present in our array, it matches. So it returned the first matching item to us. If I add a second 2 right after 3 in this array, it still won't return that duplicate. It remains the same single 2. So it simply returns whichever value matches first. Even with hundreds of values in an array, it'll return whichever one matches first. And if I duplicate this console log, remove check, and log number instead, we get the array 1, 2, 3. So it never modifies the original array. Our next method is findIndex. This returns the index of the first element that matches a given condition. It also does not modify the original array. For example, I have a variable, let number equal to an array containing 1, 2, and 3. Then below, I take a variable, let index equal to number, followed by the findIndex method. I've applied this array method, and inside it we write num, an arrow, then a strict equality check against 1. This tells us that the index of 1 is 0. If I change this value from 1 to 2, as you can see in the browser, we get 1. If I change it to 3, we get 2. So it tells us the index of whichever value matches first. If I pass in 4 instead, we get -1. Even if we leave it empty with just quotes, we still get -1, meaning no item matched at all. And if I duplicate this console log, log index, and then number, we get the original array back. Here we still have 1, 2, 3, meaning it never modifies the original array. Our next method is every. The every method checks whether every single element in the array satisfies a given condition. Let's write the code. First, let nums equal to an array containing 2, 4, and 6. Then below, I log nums using the console. Inside console log, we apply the every method on nums. It's an array method. Inside it, we write n followed by an arrow. Then n modulo 2 strictly equals 0. We get true in the browser. That's because every number here is even, not odd. 2 is even, 4 is even, 6 is even. So the condition holds true. If we add a number like 7 after 6, that changes things. Since 7 is odd, this condition no longer holds for every element. So we get false instead. So I'll remove 7 again. And if I log nums below, we get the same original array, 2, 4, 6. It never modifies the original array. Similarly, our next method is sum. The sum method checks whether at least one element satisfies the given condition. If even a single element matches, it returns true, with every single condition needed to be true. Here, even if 4 out of 5 elements fail the condition but one passes, we still get true overall. For example, I write let nums equal to an array containing 1, 3, and 4. Then below, I log nums to the console. Inside console log, we apply the sum method on nums. Inside it, we write n, an arrow, then n modulo 2 strictly equals 0. We get true. Even though 3 doesn't satisfy the condition, we still get true overall. That's what sum means. If even one condition is true, the overall result is true. Both 1 and 3 are odd here, only 4 satisfies the condition, yet we still get true instead of false. If we remove 4 and replace it with 5, we get false instead, as you can see. So, this is how the sum method behaves. Below, if I log nums, it returns our original array, 1, 3, 4. I hope you've understood how sum works as well. Our next method is slice. Slice is quite important. It gives us a copy of a portion of an array, extracting a specific segment of values. Our original array remains completely unchanged since slice doesn't modify it. Let's see this in code. First, we take a variable, let nums equal to an array containing 10, 20, 30, 40, and 50. Below, I log nums to the console. Inside this console log, I apply the slice method on nums. Inside slice, we pass in 1 and 3. Looking at the browser, we get an array containing 20 and 30. Here's what 1 and 3 actually mean inside slice. We're extracting a segment from the array. 1 represents the index we start from. It tells slice to begin from index 1. Then comes 3, which represents the endpoint we go up to. Looking at the original array, index 0 holds 10. Index 1 holds 20. So, as you can see, our result starts from 20, and that's exactly what appears in the browser. Then comes index 2, which is 30, and as you can see, that appears as well, 20 and 30. Then there's index 3, and you might wonder why 40 didn't show up. That's because 3 here only means up to, but not including index 3, so it includes indexes 1 and 2, but excludes 3. Similarly, if I duplicate this console log and comment out the top version, then in the new one, I remove 1 and 3 and just write 2 instead. Now, looking at the browser, we get 30, 40, 50. What does this tell us? In an array, we always define two boundaries, the starting index and the ending index. If you only define the starting point like this, the ending point defaults to undefined. And undefined here means there's no set endpoint, so it simply runs from the given start point all the way to the end. Since we wrote 2 here, index 2 corresponds to 30, so it starts from there, and continues all the way through since we didn't define an endpoint. Similarly, I duplicate this console log again, and in the new version, I remove 2, replacing it with empty quotes, followed by a comma and then 3. Now, looking at the browser, we get 10, 20, 30. What does this mean? Since we left the starting point empty, essentially undefined, the starting index defaults to 0. The very first index in any array is 0, so it starts from 10. Then we defined the ending point as 3. 3 here means it stops right before index 3, so it includes 10 at index 0, 20 at index 1, 30 at index 2, and stops there. This is exactly how it behaves. And if I duplicate this once more, removing the empty quotes in 3, replacing them with -2, this tells slice to start counting from the end, from the right side of the array. So -1 corresponds to 50, and -2 corresponds to 40. That's why we get 40, 50 as the result. And if I simply log nums, we still get the original array, 10, 20, 30, 40, 50. It never modifies the original array. It always returns a new one instead. Our next array method is splice. Splice functions similarly to pop, push, and unshift combined. In fact, it accomplishes all of that functionality within a single method. Splice is a method that adds, removes, and replaces elements directly within the original array. This means it directly modifies the original array. It doesn't return a new array, it changes the existing one. So first we'll declare a variable named colors. Under the name colors, let color equal to an array containing red, green, and blue. Below this, I apply the splice method on colors. I write the splice method followed by its parentheses. The splice method accepts 3 parameters. The first is the starting index, indicating where you want to begin. The second specifies how many items you want to remove or delete. The third specifies what you want to add. So we have 3 parameters: the starting point, the number of deletions, and what to add. First, we write 3 since we want to start at index 3. Looking at our array, index 0 is red, index 1 is green, and index 2 is blue. So index 3 comes right after that. We used 3 because that's where we want to apply our modification. After this, I add a comma followed by 0. Here, 0 means we don't want to delete anything. If we used any other number here, nothing would happen anyway, since there's nothing beyond that point to delete. So we use 0, meaning we don't want any deletions. Then, after a comma, I add yellow in quotes, followed by another comma, and pink in quotes. Below, I log colors to the console. Now, looking at the output, our original array has become red, green, blue, yellow, pink. It has directly modified the original array. It added yellow and pink right after blue. If I make one more change here, replacing 3 with 0, as you can see, yellow and pink now appear before red. The order becomes yellow, pink, red, green, blue. That's because 0 here represents the very first index in our array, so it starts right from the beginning. It starts there and adds yellow before the rest. If I now remove the second 0 and replace it with 3, as you can see, several items have disappeared. Red, green, and blue. Why did that happen? Let's understand the logic here. We wrote 0, meaning we start from index 0. So 0 is the first index in our array. Then we specified 3. 3 here means we want to delete 3 items starting from that point. So starting from index 0, the 3 items removed are red, green, and blue. That's why they were deleted. Then we specified 2 items to be added. Those 2 items are yellow and pink. It added them in, so looking at the browser, our array has become yellow, pink. This is how the splice method works. It's an extremely powerful method. However, it does modify our original array. There's also the toSpliced method, which we'll cover shortly, and unlike splice, it leaves the original array untouched. I'll explain that shortly. Our next method is concat. This joins 2 or more arrays together into one. For example, I write let a equal to an array containing 1 and 2. This will be our first variable, then let b equal to an array containing 3 and 4. Then, after this, let c equal to an array containing 5 and 6. We now have 3 separate arrays, a, b, and c. Below, I log to the console. Inside console log, I write a .concat. Inside concat, I pass in b and c. Looking at the browser, we get a single array containing 1, 2, 3, 4, 5, and 6. So, what does this tell us? It means all 3 arrays have been combined and joined into a single array. As you can see, it's now just one array. We started with 3 separate arrays and concat merged them together. So this method joins arrays into one, and it does not modify the original array. Our next method is sort. Sort modifies our original array directly. It arranges elements into either numerical or alphabetical order, following a specific sequence. For example, I write const numbers equal to an array containing 25, 8, 104. Below that, I apply numbers.sort. Inside sort, within the parentheses, I write a and b as parameters, followed by an arrow, then a -b. Below, I log numbers to the console. Looking at the browser, we get 4, 8, 25, 100. Notice that our original array had these numbers completely out of order. 25, then 8, then 100, then 4. To put this in simpler terms, let's replace those with 3, 2, 1, and 4 instead. Looking at the browser, we now get 1, 2, 3, 4. This is a properly ordered sequence, and before we had entered them randomly as 3, 2, 1, 4. So the sort method arranges them into numerical order. The same principle applies to alphabetical characters or letters. Let's look at an example. I take a variable const letters equal to an array containing C, A, B, and D. Then I apply letters.sort. Then I log letters to the console. Looking at the browser, we get an array containing A, B, C, D. As you can see, it's returned to us in proper alphabetical order. Originally, our array had them scrambled as C, A, B, D, but the sort method rearranged them alphabetically. If you apply sort directly on numeric values without a comparison function, it converts them into strings first before sorting, which is why we needed a callback function earlier in the numbers example. And the sort also modifies the original array. If you'd rather not change the original array, we use the toSorted method instead, which leaves the original untouched and returns a new array to us. Our next array method is reverse. As the name suggests, reverse simply flips the order of elements. It swaps the arrangement from right to left or left to right. For example, I write let numbers. And after that, let numbers equal to an array containing 3, 2, and 1. Then I apply numbers.reverse. Below, I log numbers to the console. Now I get an array where 1, 2, 3 has appeared. If you think about it, our original array had the numbers in reverse order, and reverse simply flipped them back. This means it doesn't correct the sequence, it just reverses whatever order was already there. If I replace 2 with 3 and 3 with 2 instead, we get 1, 3, 2. It doesn't behave like sort, which arranges values into proper sequence. For instance, if we applied sort here instead, we'd get 1, 2, 3, but reverse simply flips the existing order. For example, since 2 appears first in the original array, reverse places it at the end as you can see in the browser. 3 was in the middle, so naturally it stays in the middle, and 1, which was at the end, now appears first, as shown in the browser. The same logic applies if we use string values instead of numbers. It behaves identically. Our next method is join. The join method converts an array into a string while also separating its elements. This does not modify the original array. For example, I have a variable, const words equal to an array containing built, don't, and talk. Below, I log words to the console, applying the join method to it. After applying join, I simply pass empty parentheses without any argument. Looking at the browser, we get built don't talk. Notice something here, this result comes back as a string rather than an array, since join converts the array into a single string. That part is clear, but secondly, there are no spaces between the words at all. It converted the array, but didn't separate the words visually. To add separation inside join's parentheses, we add double quotes with a single space between them. Now, looking at the browser, we get built don't talk, properly spaced out. And if we log words for the original array, we still see the exact same original array. Built, don't, talk. It never modifies the original array. The next array method we have is array.isArray. This tells us whether a given value qualifies as an array, essentially checking if that value belongs to the array type. To test this, we write console log, calling array.isArray on an array containing 1 and 2. This returns true since 1 and 2 are inside square brackets, and anything inside square brackets is considered an array. If I remove 1 and 2 and just leave empty quotes instead, you'll see it returns false. Even if you place random text inside those quotes, it still returns false. So it strictly checks the actual value type. The next method we have is to sorted. We've already covered how sort works, but let's revisit it briefly and clarify the difference between sort and to sorted. First, I declare a variable using let, named numbers. Let numbers equal to an array containing 3, 1, 5, 2, and 4. Then below, I take another variable, let sorted nums equal to numbers.sort, using a comparison function of a -b. Then below, I log sorted nums to the console. As you can see, we get 1, 2, 3, 4, 5. It arranged these numbers into proper sequence. And if I check the original array by logging numbers, we see that it too has become 1, 2, 3, 4, 5. Notice that it has modified our original array. Our original array had 3, 1, 5, 2, 4, but now it shows 1, 2, 3, 4, 5 instead. The sort method changes our original array directly. It mutates it. To compare this with toSorted, let's duplicate this code. After duplicating, I'll modify sort accordingly. First, I'll comment out the earlier code above since we can't redeclare variables using let. Now we'll replace sort with toSorted here instead. Looking at the output, logging sorted nums still gives us 1, 2, 3, 4, 5. It sorted the numbers correctly into proper sequence. However, the console log for numbers below remains completely unchanged. 3, 1, 5, 2, 4. It gave us back the original array, untouched. toSorted doesn't modify the original array. It returns a new sorted array instead, leaving the original one exactly as it was. And this method was introduced recently in ES 2023. Our next method is toReversed. toReversed returns a new reversed array while keeping the original array completely unchanged. This was also introduced in ES 2023. Let's see how this works. First, we write let numbers equal to an array containing 1, 2, 3, 4, and 5. Then below, we take another variable, let reverse nums equal to numbers.reverse. We then log reverse nums to the console. As you can see, we get 5, 4, 3, 2, 1, since it reversed the order. Then below, I log numbers, and it turns out our original array was modified as well. So, as you can see, the reverse method flips the order, but it also directly changes the original array. Now, I'll duplicate this code, comment out the version above, and uncomment the one below. Now, I'll replace reverse with toReversed here instead. And now, logging reverse num successfully gives us 5, 4, 3, 2, 1. However, logging numbers for the original array remains exactly the same. 1, 2, 3, 4, 5. It never changed the original array. toReverse leaves the original array untouched, and that's the key difference here. Similarly, the last array method we'll cover, there are several other array methods, but these aren't used as frequently as toSpliced. toSpliced is the non-mutating version of splice. It returns a brand new array with the requested changes, without touching the original array, and this was also introduced in ES 2023. Let's implement this in code by taking a variable, let colors equal to an array containing red, green, and blue. Below this, we write let result equal to colors dot to spliced, passing in 3, 0, and white. Looking at the result array, white has been added at the end. Now notice something here. We logged result and got the updated array, but if we log colors, we get red, green, blue instead. It never modified the original array. Our original array stays exactly the same. Only the new copy stored in result reflects the applied changes, giving us a brand new array. Into spliced, passing 3, 0, white means start at index 3, which comes right after blue, delete 0 items, and then add white. Our first console log for result gave us red, green, blue, white, while the console log for colors gave us red, green, blue. And that brings us to the end of array methods. We've covered array topics in considerable depth, focusing on the methods used most frequently in real-world development. There are certainly other methods out there as well, such as flat and several more. If you'd like to explore and master those further, the MDN website covers every method in detail, though as a beginner, it isn't strictly necessary right away. Once you've worked with JavaScript for 2 or 3 years, you can explore those additional methods later. As a beginner, diving into them too early might just leave you stuck. So I hope array methods are now clear to you. Our next topic is callback functions. And a callback function is a function that we pass as an argument into another function. To give you a real-world scenario, think of a restaurant. First, we place an order, and once the cook finishes preparing it, the waiter calls us by name, which is exactly how a callback function works. Until our task is completed, it doesn't get called. Let's move to the code so you can understand this better. First, we'll create a function named greet, taking name as its parameter. Inside this function, we log to the console, writing welcome followed by a comma and then name. So far, nothing appears in the browser yet. Below this, we'll create another function named user, which takes callback as its parameter. And inside it, we call callback, passing in the string John. Now we'll call user and pass greet into it, and as you can see, we get welcome John. Let's break down how this is actually working. First of all, we have a regular function here, and we've named this function greet. So right now, we've simply created this function. Nothing happens yet since we haven't called it directly. After this, the second function we created accepts callback as a parameter. Here, callback is simply a parameter that stores the function passed into it. Inside the user function, we call callback with John. What this means is that since we supplied John here, greet will use John as its output. That's exactly how JavaScript interprets it. On the next line, where we call user and pass greet into it, this is what actually invokes the function. Now notice that we haven't added parentheses after greet. That's simply not needed here since it executes right away once called. Next, our topic is higher order functions. A higher order function is one that either takes another function as an argument or returns a function. Let's understand this through code. First, we'll create a function named calculate, taking 3 parameters. The first will be a, the second b, and the third operation. Inside it, we write return operation, passing in a and b, the 2 values we want to perform the operation on. So inside operation, I pass in a and b. Nothing happens yet since we haven't invoked it. On the next line, we'll create another function named add, taking x and y as parameters, and inside this function, we return x plus y. X plus y represents the values for the addition task we want to perform. Below, we log calculate to the console. Inside it, we call calculate, passing in 3 arguments, 5 for x, 5 for y, and add as the operation. Looking at the output, we get 10. Let's understand how this works. The values we passed into calculate can be read as a is 5, b is 5, and operation is add. And where we wrote a and b inside operation, this line effectively tells JavaScript to treat operation as add. And inside add, we're working with the values 5 and 5. Since we're adding 5 and 5, the result naturally comes out to 10. Here, add passed into calculate is our callback function, and calculate itself is a higher order function, since it accepts a function as an argument. Put simply, the difference between a callback function and a higher order function is that a callback is passed into another function, while a higher order function accepts or returns another function. A callback function gets executed by another function, whereas a higher order function works directly with function values. In short, a callback is the function being passed in, while a higher order function is the one receiving or returning another function. We won't dive any deeper into this. Since we don't use this pattern too often, we mostly rely on regular functions and arrow functions in practice. And with practice, you'll come to understand it naturally on your own. Our next topic is iterators. An iterator is an object that lets us access one value at a time from a collection, such as arrays, strings, sets, and similar structures. Think of it like accessing values from a collection one step at a time. First the first item, then the second, then the third. It doesn't access every value all at once. For example, looking at the code, I have a variable colors assigned to an array containing red, green, and blue. So we have a colors array holding red, green, and blue. Now to apply the iterator method, I'll create a variable named iterator assigned to colors, and since colors is an array, I access it using square brackets. Inside the square brackets, we write symbol.iterator. Then, outside the brackets, I add a set of parentheses. After this, I log iterator to the console, and along with it, I call its next method using parentheses. Now looking at the browser, we get an object containing the value red and done set to false, since it isn't finished yet. Calling this a second time gives us the array's second value, green, with done still set to false. The third time we call next on the iterator, by duplicating the console log, we get an object where the value is blue and done remains false. The fourth time we duplicate this console log, we see the value has become undefined and done has switched to true. What does that tell us? What exactly does this mean? In simple terms, calling next returns an object to us each time. As long as there are elements remaining in the array or collection, we get the current item's value with done set to false. And once we reach the end, with nothing left, we get undefined and done switches to true. Imagine, for instance, an array containing 10 million colors. Instead of loading every single value all at once, the JavaScript iterator processes them one at a time. It goes through them one by one, which conserves memory, and that's its key benefit. Now you might wonder, for this one-by-one iteration, if our array had thousands of items, would we really call next manually 1,000 times just to display everything? No, definitely not, because there's already a solution for that. And that solution is the for of loop, which automatically handles the iteration process behind the scenes. Instead of repeatedly calling next yourself, you simply write a for of loop, and it takes care of everything. So first I'll write for, but before that, I'll comment out all the console log statements above, along with the iterator variable. I'll leave only the colors array in place, since that's what we need to apply the for loop on. First we write for, and inside the parentheses, we write const color of colors. And inside the loop body, we log color to the console. Now looking at the browser, you can see we get red, green, blue. If this array held thousands of colors, this loop would still handle it in just these 2 lines. Whereas without a for of loop, manually calling next repeatedly would require thousands of calls. Similarly, if I take another variable, words assigned to John, and apply a for of loop below it, writing for, and inside parentheses, const letter of words, and inside we log letter to the console. Now, looking at the browser, you can see we get JOHN. So the for of loop iterates over values. And to explain the difference between for of and for in loops, simply for of loops through values, while for in loops through keys, which can be array indexes or object property names. That's the key distinction between the two. We won't go any deeper here. This covers what you need to know. Our next topic is generators. A generator is a special kind of function that can pause and resume execution. A normal function runs straight through from start to finish, but a generator starts, pauses again, resumes again, and eventually finishes. That's how it behaves. So here's what we'll do. First, we'll create a function, and alongside the function keyword, we'll add an asterisk symbol. This is the key difference between a generator and a regular function, the presence of that asterisk. After this, I'll give the function a name calling it demo. Inside it, I log start to the console. Then below that, we write yield1. Then below that, we log middle to the console. Then below that, we write yield2 followed by logging end to the console. Now outside this function, below it, I'll create const result, assigned to calling demo invoking the generator, and below, I log result.next to the console. As soon as I run this, you can see we get start printed as plain text, along with an object containing the value 1 and done set to false. Meanwhile, the remaining values, like middle and end, haven't appeared yet. So when I duplicate this console log, you can see we get middle printed, along with an object where the value is 2 and done is false. Similarly, duplicating the console log a third time gives us end, along with an object where the value is undefined, and done has finally switched to true. So what does all this mean? What exactly does yield do here? Yield works by pausing execution at that exact point. It pauses the function and returns a value back to us. Calling next again resumes execution from where it left off. In other words, the function halts precisely where the yield keyword appears. Its main purpose comes into play when dealing with large data sets or infinite sequences, where generators become especially useful. Our next topic is a particularly interesting one that's used quite frequently in real-world JavaScript projects. That's the optional chaining operator. This is a JavaScript syntax feature introduced in 2020. It's a modern addition falling under modern JavaScript features. So, what exactly does it do? It lets us safely access properties within deeply nested objects or arrays. This helps us avoid runtime errors whenever a property turns out to be null or undefined. Let's see what that means in practice. For example, I'll take a variable, let user, set to an object containing name John. I've created an object called user holding name John. Now below this, I log user.address.city to the console. Looking at the output, we get an error. So, what's the error telling us? It says, cannot read properties of undefined reading city, since user.address itself is undefined. It's telling us it can't access the city property because address doesn't exist on user. So our application has crashed right here. For such a small oversight, should we really let the entire application break down? Obviously not, and that's exactly why we use optional chaining, applying a question mark followed by a dot wherever needed. So here's how we rewrite it. We write user, followed by a question mark, then a dot, then address, followed by another question mark, a dot, and then city. Now looking at the output. What do we get in the browser this time? Undefined. Here, undefined simply indicates that the property doesn't exist. Our application hasn't crashed at all. There's no error, just a clean, undefined value. Similarly, if you'd like to provide a fallback value. For instance, if the value doesn't exist, we can display a default instead. So after city, we add a double question mark followed by unknown in quotes. Now, instead of undefined, we get unknown displayed. And that's essentially how optional chaining works. We can apply this same approach to arrays as well. I demonstrated it on an object here. Arrays are left for you to practice on your own. Try applying it to arrays yourself so you get some hands-on practice too. I hope all these concepts around modern code and cleaner data handling now makes sense to you. Our next topic is a genuinely important one, and most beginners tend to get confused by it, often staying confused for quite a while. Until you go through this 4 or 5 times and dedicate 5 to 6 hours of practice. Without that repetition, the confusion around this topic could linger for years. That topic is this keyword in JavaScript. This is arguably the most confusing concept in all of JavaScript. That's because its value depends entirely on where the function is called from, not where it was originally written. So, what exactly is this? This is a special keyword that refers to the object currently executing our function. I understand that definition alone probably doesn't make much sense yet. Let me walk you through a real-world analogy instead. Imagine you have a teacher. Picture a teacher who visits different schools. Say, they visit 3 schools, which we'll call School A, School B, and School C. When they visit School A, the students there refer to them as our teacher. When they move to School B, those students also call them our teacher. And at School C, the students there say the exact same thing. Our teacher. Here, it's the same teacher throughout, just visiting different schools. Does the meaning stay identical everywhere? We only have one teacher, let's say his name is John. But as he moves between schools, students at each one refer to him as our teacher. That phrase, our teacher, carries the same words but different meaning each time. Its meaning shifts depending on whether it's School A, School B, or School C. Here's how that works. At School A, one set of students says, our teacher. At School B, a different group says it. And at School C, yet another group says it. So when students say, our teacher, the meaning of our changes across these 3 schools. The word our takes on a different meaning each time. The teacher himself stays the same person, but the meaning shifts depending on which school is speaking. Why does that happen? Because whoever is speaking exists in a different context each time, and that context shapes the meaning. The behavior of this works in exactly the same way. It changes based on where the function containing this is actually called from. Who is doing the calling matters. Once we look at actual code, this will click a bit more. For example, let's create a function named sayName. Inside this function, we log this .name to the console. This is simply a regular function called sayName, where we're printing this .name. We won't unpack what this and .name mean just yet. We're just observing the output here for now. Nothing appears in the browser right now since we haven't invoked the function yet. After this, what do we do next? We create a variable, const school A, set to an object. Inside the curly braces, we add name:\John, and alongside that, we include sayName. So we've created an object called school A containing name John and sayName, referencing the function we defined earlier. We're not calling this function directly here, just referencing sayName without adding parentheses after it. Now we'll create a second object, const school B. Inside the curly braces, I write name:\Harry's, and again include sayName. Just like school A, where the name was John, here the name is Harris instead. Similarly, we create a third object, const school C, with name:\Alice inside the curly braces, followed by sayName below it. So now we've created 3 separate objects, and in each of these 3 objects, we've referenced the same sayName function. As you can see, it's identical across all 3. Now, what comes next? At the very bottom, we write school A.sayName, followed by opening and closing parentheses to actually invoke it. This means we're calling the sayName function through the school A object using dot notation. As you can see, we get John printed in the browser. So how exactly did that happen? Let me walk you through why this result appears. Next, what do? We call school B.sayName, invoking the function through that object. Now we get Harris printed in the browser. Third, we call school C.sayName, and now we get Alice. You might be wondering, how does calling sayName from school A correctly return John, from school B return Harris, and from school C return Alice? Let me clear up this confusion for you. The sayName function itself, where we log this .name, has no built-in knowledge of what name it should use or where that value comes from. This, and remember this point carefully, waits until you actually call it from within a specific object. Wherever you invoke it from, it pulls the value from that exact context. Going back to the definition of this, it refers to the object currently executing the function. Here, school A is the object, and it's the one executing the say name function in this case. So the meaning of this shifts accordingly. Within school A, this dot name resolves to John. Within school B, that meaning changes entirely, no longer John, but Harry's instead, because that's where we executed it from. And within school C, the name becomes Alice. So wherever you call the function from, whichever object it's invoked through, its meaning depends entirely on what that specific object contains. Because that's fundamentally what this represents. Earlier, when we defined say name, it had no idea what name or this dot name would resolve to. It simply waits until it's called. So calling it from within school A pulls the name John from there. Calling it from school B pulls Harris, and calling it from school C pulls Alice. It's really that straightforward. Let me share a golden rule with you. Follow this and you'll never get confused by the this keyword again, whenever you're unsure about what this refers to. Don't focus on where the function was originally written. Instead, focus on how and where the function is actually called. Building this single habit will make working with this keyword in JavaScript far easier. There's no need to trace back to where the function containing this was defined. What matters is tracing where it's actually invoked, because its meaning depends entirely on the calling context. I won't go any deeper here. Spend 3 to 4 focused hours practicing this consistently over 10 to 15 days, and I guarantee it'll save you months of confusion down the line. This is one of the most important topics you'll encounter, since out of every 10 interviews, roughly 9 will include questions related to this keyword. There are rare exceptions where it doesn't come up, but in about 90% of interviews, expect questions on this keyword, along with related methods like bind, call, and apply. We'll cover those shortly, but first, it's essential that you fully grasp what this actually represents. Now, let's go over a few rules governing this keyword. The first rule is default binding. Default binding applies when a function is called on its own without being attached to any object. In that case, this follows the default rule. For example, let's write a function named sayHello, and inside it, log this to the console. Below, we invoke this function directly by calling sayHello. Now, as you can see, we get window printed in the browser. In non-strict mode, we get window, while in strict mode, we get undefined instead. There's no need to fully understand strict mode right now, because in this case, the function has no object attached to it. So who exactly owns it? Since it has no owner, it defaults to the surrounding environment, which gives us window. Our second rule is implicit binding. Implicit binding occurs when a function is called through an object. We've already touched on this concept earlier, but let's walk through another quick example. For example, let's take a variable, const user, creating an object named user containing name John. Right below name John, we add a greet property, which is a function. So we write greet as a function, and inside its body, we log this dot name to the console. At the very bottom, we call user.greet, and we get John as the result. Why did we get John specifically? That's implicit binding at work, since our object is the one calling the function here through user.greet. So who owns it in this case? The object does. Earlier there was no owner at all, which gave us window. Now we get John, because an actual object is present and executing the call. Our third rule is explicit binding. With explicit binding, we manually decide what this should point to. Methods like call, apply, and bind all fall under this category. Let's start by understanding what call does. Call executes our function immediately, and we explicitly specify what this should refer to within our target object. The additional values we pass along are supplied individually as separate arguments. To see this in action, we'll write a function named greet, taking 2 parameters, location and time. I've already covered parameters and how they work within functions, so I won't go over that again here. Inside this function, we log something to the console. Within that console log, we'll use template literals, and since I've already explained template literals earlier, I won't dive deep into that again to avoid repetition. To build the template literal, we use backticks. starting with the static text. Hello, my name is A. Then, to insert a dynamic value, we add a $sign followed by curly braces containing this dot name. Outside those braces, we continue with welcome to E. Next, to add another dynamic value, we insert a $sign with curly braces containing location. Outside those braces, we continue with in the. Then, we add a $sign with curly braces containing time. At this point, our console log statement is complete. Below this, we create an object, since this keyword depends entirely on it. So we write const person, containing name John inside the object. Now below this, here's how we call our function. First, we write greet, then chain on dot call. Call, as I mentioned earlier, is a method that runs the function immediately, specifies what this should point to, and accepts individual values as separate arguments. Inside call, we pass in person. Person here is our target object. What are we pointing this to here? We're pointing it directly to that object. That's exactly the purpose of call, pointing this at an object, which is why we passed in person. After that, we add a comma to separate the arguments, followed by New York in quotes. Then another comma outside the quotes, followed by morning in quotes. Now, looking at the browser, we get, hello, my name is John. Welcome to New York in the morning. For instance, if I remove New York and morning, you'll see, hello, my name is John. Welcome to undefined in the undefined. We get undefined appearing twice in that case, but once I add New York and morning back in, the full message, welcome to New York in the morning, returns as expected. As I mentioned earlier, call passes individual values as separate arguments. Here, those individual values are New York and morning. And New York corresponds to the location parameter from earlier, while morning corresponds to time. So that covers the call method thoroughly. I hope it's clear now. The second method we have is apply. Apply also invokes the function immediately, but here, we pass the additional values as a single array instead. With call, the values were passed individually one after another as separate arguments. We still pass individual values with call, obviously, but apply lets us bundle them together inside an array instead. Apply behaves just like call. The only real difference lies in how the extra arguments get passed, packed into a single array rather than listed one by one. So with call, we pass items individually as arguments, whereas here, we group them into a single array. For example, now let's see what changes we need to make. First, we replace call with apply right after greet. Then, for our two values, right below the person object, we create an array named details, using const details equal to an array. Inside the square brackets, we write New York, followed by a comma, then morning. And inside greet, we remove New York and morning that were following person. Here, we simply add details instead. Now, as you can see, we still get, hello, my name is John. Welcome to New York in the morning. So that's essentially the key difference between the two. Both call and apply run the function immediately. The only distinction is that call passes values individually, while apply bundles them into a single array. The next method we have is bind. So, what exactly does bind do? Unlike call and apply, which execute the function right away, bind doesn't run the function immediately. Instead, it creates a permanent, reusable copy of the function, returning a brand new function to us, and it locks in whatever object you specify as its permanent target. You can then invoke this new function whenever you're ready. Just as before, let's duplicate the code from above. I'll completely remove the details array we created earlier. And where we had greet.apply, I'll replace apply with bind instead. After person, I'll remove details and instead add two values directly. First, New York, then morning. And we'll store the result in a variable, so before greet.bind, we write const bound greet equal to. Now our code reads as const bound greet equal to greet.bind. Now when we invoke this function, we simply write bound greet followed by parentheses. Having invoked it now, you can see, hello, my name is John. Welcome to New York in the morning. Appears in the browser console. So it returned a brand new function to us. It didn't run the function immediately. That's precisely why we call it bind. Our fourth rule is new binding, so when do we actually use new? In JavaScript, new means creating a completely fresh object, and this concept ties directly into constructor functions. A constructor function is essentially a regular function that we invoke using new. Once we do that, it behaves as a constructor function. Let's walk through this in code to see exactly how it works. First, we'll create a function named person. But this function won't behave like a typical regular function. It will act as a constructor function instead. The only real difference between a constructor function and a regular one lies in naming convention. A regular function, like person written here, starts with a lowercase letter. A constructor function, on the other hand, starts with an uppercase letter. That's the key distinguishing factor. So we've created a constructor function called person, taking name as its parameter. Inside the person constructor's body, we write this dot name equal to name. Below this, we take a variable, const p1 equal to. Here, we add the new keyword in front. New signals that we're creating a fresh object, so we write person, passing in Ali as the argument, and below we log p1 to the console. As a result, we get an object where name is Ali. So overall, does this clarify the concept behind constructor functions for you? And since the new keyword generates a brand new object, as you can see, we get back an object containing name Ali. I hope that this keyword, along with its rules and related methods, now makes complete sense to you. Understanding truly comes through practice. Simply watching won't get you there. Here's your task. Pause this video and carefully study through the code I've written so far. Once you've analyzed it thoroughly, erase it and rewrite it entirely on your own. You'll likely hit errors on nearly every line the first time, but by your second attempt, you'll probably reduce that down to just 3 or 4 lines. By your 4th or 5th attempt, you'll reach a point where you won't encounter a single error, and you'll be writing it fluently without getting stuck anywhere. Our next topic, and also our final one, covers 3 important areas: callback limitations, promises, and thirdly, async and await. These 3 topics are genuinely important. All 3 accomplish essentially the same underlying goal. However, each comes with its own distinct advantages, and we rely on them heavily in advanced JavaScript development. Whenever we handle asynchronous tasks, these 3 come into play. We've already covered callback functions, but let me recap briefly. A callback is simply a function passed into another function, so it executes later, one step at a time. However, when multiple functions get nested inside one another, one function inside another, then inside yet another, it turns into what's known as callback hell. So why does this situation arise in the first place? Well, whenever a task takes time to complete, such as downloading a file which doesn't finish instantly but happens gradually, or querying a database or making an API call, these operations naturally take time. And since JavaScript runs on a single thread, executing code line by line, it simply can't pause and wait indefinitely for that operation to finish. So, without properly implementing these 3 concepts in our code, our application risks crashing entirely, since every line often depends on the ones that come after it. First, we need to understand how JavaScript actually behaves under the hood. And for that, we need to explore another topic entirely, the event loop, which is fairly extensive and falls outside the scope of this course. It's a fairly advanced topic at this stage, so if you'd like a dedicated video covering the event loop, let me know in the comments and I'll put one together. JavaScript operates on a single thread, meaning code executes sequentially, line by line, from top to bottom. For example, if we make an API call involving thousands of records within an array or object, and that call happens at, say, line 50, the request itself will naturally take somewhere between 3 to 5 seconds to complete. So, while that API request is still processing, if the code beneath line 50 continues executing without waiting for the response, our application would crash outright. That's exactly why we use these 3 concepts, so JavaScript can wait patiently for our API integration to complete, while still allowing other parts of the code to run in the meantime. It doesn't halt the execution of everything else around it. Here's a real-life comparison. Think about doing laundry instead of standing beside the washing machine for the full 30 minutes. You naturally go do something else, watch TV, grab a meal, and once the wash cycle finishes, the machine simply stops on its own. This is essentially how callbacks operate. As for callback hell, it's sometimes referred to as the Pyramid of Doom, because the resulting code visually forms a triangular shape, making it notoriously difficult to manage. As projects grow larger, managing this kind of nested code becomes increasingly challenging. Reading it, debugging it, handling errors properly, reusing pieces of it, or maintaining it cleanly all become genuinely complicated. So, to address this problem, promises were introduced. This approach helps eliminate deep nesting and allows for cleaner, chainable operations. So, what exactly is a promise? A promise is an object representing the eventual result of an asynchronous operation. Think of it this way. I make a commitment to you, and I'll deliver the outcome later, whether that turns out to be success or failure. Here's a relatable analogy. Imagine a friend telling you, I promise I'll return your book tomorrow. At that exact moment, you don't physically have the book yet, but you trust that eventually you'll either receive it back successfully or hear something like, sorry, I lost it. That's essentially how a promise operates. Every promise exists in one of three possible states: pending, fulfilled, and rejected. Pending describes the period while the task is still underway, like a file that's actively downloading, since that naturally takes time. Fulfilled describes the moment the operation completes successfully, like when that download finishes. Rejected occurs whenever something goes wrong internally, like a network error, preventing the download from completing, so it always begins in a pending state. While pending, the outcome can eventually go either way, succeeding or failing. If it succeeds, it becomes fulfilled. If it fails, it becomes rejected. That's roughly how the whole process unfolds. Within a promise, we primarily rely on two methods, then and catch. We use then to handle success and catch to handle failure. Just as deeply nested callback functions lead to callback hell, promises give us promise chaining as an alternative. Promise chaining is a clear improvement. It involves less nesting, reads more clearly, handles errors more gracefully, forms a clean sequential chain, simplifies debugging, and makes ongoing maintenance far easier. Now, just as promises improved on callbacks, they still carried some complexity compared to async and await, which eventually led to their introduction. Promises are genuinely useful, but they can still feel somewhat complex, whereas async and await feel remarkably straightforward. JavaScript introduced this feature specifically to make asynchronous code read and behave almost exactly like ordinary synchronous code. We place the async keyword directly before a function, and that function will always return a promise, even when we simply return a plain value. The await keyword pauses execution within that async function until the underlying promise settles, meaning it either resolves successfully or fails. It doesn't block the entire JavaScript program or any other running code. Everything else continues to execute normally. It simply pauses that particular block of code until it's ready to proceed. In short, it waits patiently until the data finishes fetching, then moves forward. Just as promises use then for success and catch for errors, async and await rely on try and catch blocks instead. The try block contains the code that runs when everything succeeds, while the catch block handles any errors that occur. There's also a finally block, though we won't cover that just yet. We've covered plenty of theory so far, so now we'll actually write code for all three approaches, compare them directly, and you'll clearly see how each one performs and behaves. So first we'll create a function, naming it washClothes. That's the name we'll give this function. In its parameter, we'll accept callback. And inside its curly braces, we'll include setTimeout. Now, setTimeout might feel unfamiliar to you, so let's clarify what it actually does. setTimeout is a built-in JavaScript function that executes a block of code after a specific delay. When we write setTimeout, we follow it with parentheses, and inside, we pass in an arrow function. Then, inside that arrow function's curly braces, we log clothes washed to the console. Below this, we call callback. And within setTimeout, we specify a delay, setting it to 2000 milliseconds. 1000 milliseconds equals 1 second. So here, 2000 milliseconds equals 2 seconds, meaning this will execute after a 2-second delay. Below, we'll create another callback-based function, naming this one dryClothes. And in its parameter, we again accept callback. We add curly braces, and inside them, we again include set timeout. So what I'll do is copy the set timeout code from above and paste it here. We'll only update our console log, replacing washed with dried. Similarly, we'll create a third function. Rather than writing it fresh, we'll simply duplicate the previous one. And we'll rename dry clothes to fold clothes. And in our console log, where it currently says dried, we'll replace that with folded. Right now, nothing appears in the browser just yet. We'll now call and invoke these functions. So our first function is wash clothes, so we call wash clothes. And inside wash clothes, we pass in an arrow function, and within that arrow function, we call dry clothes. We've passed one function as an argument into another. Now inside dry clothes, we again include an arrow function, and inside it, we call fold clothes. We're calling this third function here. And inside this third function, fold clothes, we bring in yet another arrow function, and within it, we log laundry finished to the console. Now let's look outside at the browser. How does this actually play out? Upon refreshing the browser, after 2 seconds, clothes washed appears. Then, after another 2 seconds, clothes dried shows up, followed by clothes folded and laundry finished together, after a final 2-second delay. If you look closely, we have one callback function nested inside another, then a third nested within that. This is exactly what we call callback hell. For instance, right now we only have 3 functions stacked together. Imagine if we had 20 functions instead. Below, inside wash clothes, we call dry clothes. Then inside dry clothes, we call fold clothes. And imagine 20 more layers stacked beyond that. Would managing something nested this deeply actually be practical? If an error occurred somewhere inside dry clothes, how would we even trace where it originated? We wouldn't be able to handle that error properly at all. So, with 20 nested functions, maintaining this structure would become extremely difficult. That's precisely why we turn to promises, using promise chaining instead. We'll implement that too, but it's essential you first understand callback hell and how everything appears step by step after each 2-second delay. It doesn't all appear simultaneously. That's essentially how this behaves. Now let's compare callback hell directly with promises. So here's what we'll do first. For convenience, so we don't waste time rewriting everything, we'll copy our 3 existing functions, wash clothes, dry clothes, and fold clothes. We'll copy these 3 functions and paste them below. Now we'll comment out our earlier callback-based versions to avoid naming conflicts. For the version we just pasted below, we'll make a few adjustments. So what exactly are we changing? The very first change needed to convert this into a promise involves using the Alt key. Holding Alt and clicking wherever edits need to happen. So press Alt on your keyboard, and wherever we have callback listed as a parameter across all 3 functions, in wash clothes, then dry clothes, then fold clothes, we'll remove it entirely. We don't need that parameter anymore within promises. Second, here's what we need to do. Looking through each function, wash clothes, dry clothes, and fold clothes, we currently reference callback inside each one. In every instance, we'll remove it, selecting callback across all 3 functions using Alt, deleting it, and replacing it with resolve instead. Alongside resolve, we add opening and closing parentheses. That change is now complete as well. The third change is particularly important, and understanding it will help you avoid errors down the line. Here's what we'll do, placing our cursor at the very top of wash clothes, then dry clothes, then fold clothes. Within each of them, on the very first line after selecting all 3 simultaneously, we write, return new promise. And inside the promise, we pass in an arrow function as its parameter, taking resolve as its own parameter, followed by curly braces. Inside those curly braces, I'll move our existing set timeout code directly into the promise. So follow along exactly as I'm doing here, and you'll steer clear of any errors. That step is now complete. Our functions have officially become promises. So what comes next? We'll call them, but instead of relying on callback hell, we'll use promise chaining. I've already walked you through what promise chaining involves. First, we write wash clothes, followed by parentheses to actually invoke it. Below that, we press enter to keep the formatting clean, then add a dot followed by then. Inside then, we call dry clothes. Then, pressing enter again on the next line, we add a dot followed by then, and inside it, we call fold clothes. Then, on the third line, we add a dot followed by then, and inside it, we include an arrow function. And within that arrow function, we log laundry finished to the console. Now, let's refresh the browser and take a look. You can see that after 2 seconds, clothes washed appears. Then, after another 2 seconds, clothes dried shows up, followed by clothes folded and laundry finished together after the final delay. So, without comparing the remaining code line by line. Simply compare callback hell above with its deeply nested structure against promise chaining below using then, and the version using then clearly reads much more simply. This represents genuine progress. Callbacks came first, followed by promises. Promises represent a meaningful step forward. It's a solid improvement, wouldn't you say? It's genuinely satisfying resolving callback hell through clean promise chaining. Beyond this, even promise chaining can feel somewhat cumbersome at times, which brings us to async and await, an even more powerful approach. So to get there, here's what we'll do first. We'll take our 3 existing promise-based functions, wash clothes, dry clothes, and fold clothes, copy them, and paste them below, commenting out the earlier versions to prevent conflicts. Now we have these 3 ready. We won't modify these internally. Instead, we'll wrap this entire process using async. Here's how we apply async. First, we add the async keyword, and then we write function, since async always precedes the function keyword. So we apply the function keyword, giving this new function any name we like. I'll call it do laundry. Within it, we open curly braces. Inside these braces, we include the await keyword. So what exactly does await do? It pauses execution, waiting, and that's the key concept to grasp here. Following this, we call our first function, wash clothes. Right below, alongside wash clothes, we add opening and closing parentheses. Then, on the next line, we write await, followed by dry clothes. On the third line, we write await, followed by fold clothes. And below, we log laundry finished to the console. Now we'll invoke this function, calling our async function, do laundry, directly. Refreshing the browser now, you'll see the sequence unfold. First, clothes washed appears, then 2 seconds later, clothes dried shows up, followed by clothes folded, after another 2-second delay, and finally laundry finished completes the sequence. So now compare all 3 approaches. We've accomplished the exact same task using callback hell, promises, and async with await. Yet callback hell proved considerably more complex compared to both promises and async and await, and promises in turn were somewhat more complex compared to async and await. Ultimately, async and await comes out as the clear winner. Now, you can see the async version reflected exactly in the code where we're calling it below. So, weigh callback hell, promise chaining, and async and await against one another. Which approach feels most intuitive to you? We'll typically default to async and await going forward, though we'll still reach for promises depending on the specific situation. And with that, we've wrapped up our final topic. I hope everything made sense along the way. Next, we'll put this async and await knowledge into practice, integrating it directly into our project, since it depended entirely on API integration. Since our project relied on this, we'll now use async and await to perform an asynchronous operation and properly integrate the API so you can see it applied in a real context. So I've reopened our earlier project, which is partially built with some pieces still remaining. You can see on the right side, the browser is already running through Live Server. Go ahead and open Live Server on your end too. You already know how to set that up. First, let's scroll down within our code, and right below our window, .add event listener, click handler will begin. Create a new function. This will be our calculation conversion function. The purpose of building this function is that right now, our dropdown functionality already works fine, but 2 specific pieces are still missing. First, our swap button isn't functioning yet. And second, we're missing a live value, since that needs to come directly from the API. So before we tackle that, whenever we integrate an API, that process typically takes 2 to 3 seconds to complete, since it's fetching live data. This depends partly on network conditions and partly on how much data the API happens to return. To properly handle this kind of delay, we'll rely on async and await. We could technically use promises or plain callbacks too, but we'll go with async and await since that's the standard approach used today. So right below our window, .addEventListener, we begin writing window. Actually, let's first add the async keyword. Following that, we write function since async always comes before the function keyword. Then we name this async function calculate conversion. Inside its curly braces, we begin declaring variables. We'll mostly rely on const here, so we declare const from currency, setting it equal to from dropdown.value. As I explained earlier what from and to represent, here we're simply reading the value from our first dropdown, using .value to track whatever gets selected. After this, we need a similar variable for the second dropdown since we want to track that value too, so we write const to currency equal to toDropdown.value. With this in place, we can read its selected value directly and JavaScript will pick it up accordingly. Similarly, we'll assign a default value for amount. Third, we declare a variable named amount, const amount, so we can read the entered value, setting it equal to parsefloat applied to amount input .value. So what exactly does this accomplish? Parsefloat converts a string value into an actual number. For example, if the user types in 100, the browser initially returns that as text. So this conversion turns it into a usable number for calculations. A string and a number aren't considered equal in strict comparisons, so we specifically need a proper number here, which is exactly what this conversion ensures. Following this, amount input.value reads the raw input, and afterward, we add the logical OR operator followed by 0. This protects us from calculation errors, preventing unexpected failures. In other words, if the result turns out to be not a number, it defaults safely to 0 instead, keeping our calculations error-free. Below this, we declare a variable named API-URL. For API-URL, you'll need to insert the actual API endpoint you're using to fetch live currency exchange data. I've already sourced one myself, and you're welcome to find your own. Feel free to choose whichever service works best for you. Here we'll rely on template literals again, using backticks for our template literal. And here, I'll paste in the base URL. The API I'm integrating follows the pattern of specifying a base currency as part of the query. Now, within that base parameter, if you want to target a specific currency, you'll need to define it explicitly right there. If you specify USD, that represents the US dollar. If you specify EUR, that represents the euro. But we won't be limited to fetching just one currency. We'll need roughly 6 different ones: US dollar, euro, Pakistani rupee, Indian rupee, Japanese yen, and Canadian dollar. Since we need all of these, here's what we'll do. Right after the equal sign, we'll insert a $sign followed by from currency inside curly braces. This means that, for example, looking at the browser, if I open this dropdown, I see various currency options listed. If I select EUR here, from currency automatically becomes EUR. We'd retrieve the euro's corresponding value. If I select PKR instead, from currency becomes PKR accordingly. So this needs to update dynamically based on user selection. Just as promises rely on then and catch for handling success and errors, async functions rely on try and catch blocks instead. So first we set up a try block, and right after the closing brace of try, we add a corresponding catch block. For catch, we include parentheses containing error, followed by its own curly braces. Now let's populate the try block first. Inside try, we begin with a variable const response, which we set equal to an awaited fetch call. We call fetch, passing in API URL as its argument. This call is now paused, awaiting a response. Recall what await actually does here. It's specifically waiting for API URL's data to arrive. If we skip the await keyword entirely, an error will occur, since execution won't pause properly and the application would crash. And fetch, a term you've likely encountered before, is what actually sends the HTTP request to reach that API. And await ensures that whenever the API needs additional time to respond, execution handles it gracefully. Essentially, it pauses this async function until the API successfully returns its response. Without a wait, the following line of code might execute before the data has even arrived. If we skip a wait entirely, subsequent code would run prematurely before any data actually arrives. Following this, we introduce an if statement. Within this statement, we check whether response.ok evaluates to false. Essentially, whatever reply the API sends back gets stored inside our response variable. And through this conditional check, we determine whether our request actually succeeded or not, examining whether response.ok comes back true or false, meaning a successful request naturally returns true, and if something goes wrong along the way, it returns false instead. Here we've applied a negation using not. Not effectively flips this, checking whether the request was unsuccessful. So if the request wasn't successful, we throw a new error, generating one and passing in the message, failed to fetch exchange rates within quotes. After this, we declare another variable named data, const data, setting it equal to an awaited call to response.json. Now, what exactly does this represent? JSON stands for JavaScript Object Notation. You might be encountering the term JSON for the very first time here, since we haven't touched on it throughout this course. Keep in mind that as you build real-world JavaScript projects, you'll continuously run into new concepts, research them as needed, and gradually become comfortable with them over time. Covering every single term within a single course simply isn't feasible, or the course would become excessively long. Now let's understand what response.json actually accomplishes. AP is typically return data formatted specifically as JSON. JSON format differs structurally from a standard JavaScript object. Looking at this example, our raw JSON data appears formatted exactly like this, as shown here. Here, calling JSON essentially converts that raw JSON data into a standard JavaScript object we can work with directly, and we've applied a wait here once again, since parsing that response naturally takes a brief moment, requiring us to wait for it. After this, we declare another variable, const rate, setting it equal to data.rates. And within data.rates, we access it using square brackets, passing in the target currency as the key. So what exactly does this accomplish? Suppose our target currency happens to be PKR, returning its corresponding conversion value. JavaScript reads that value directly and returns it for us to use. After this, we declare another variable below, const converted amount, setting it equal to amount. Multiply directly by rate. This is simply straightforward multiplication. For example, if our amount happens to be 100 and the rate comes out to 83, multiplying the two together gives us roughly 8,325. It's really just simple multiplication. Similarly, below this, we handle displaying the actual result. And for that, we apply the text content property. I've already covered DOM text content earlier in this course, so I won't go over what text content means again here. And this gets set equal to converted amount dot to locale string. So what exactly does this accomplish? Converted amount holds our previously calculated multiplied value, and to locale string formats numbers in a way that's easier to read. Within this, the first option we pass in is undefined, followed by a comma. Then within curly braces, we specify minimum fraction digits as 2 and maximum fraction digits as 4. I'll demonstrate exactly how these two settings behave once we run the complete application, so at the end, you'll be able to compare the results clearly and understand them fully. To briefly illustrate here, if the result happens to be 25, it would display as 25.00. And if the value came out to something like 1,234,567.8, it would format nicely with comma separators and decimal precision. That's essentially how the formatting behaves. This setting caps the maximum number of decimal places at 4. Below this, we set rateText.text content, setting it equal to using template literals once again. Within the template literal, we start with the number 1, followed by a $sign and curly braces containing base currency, followed by an equal sign, then another $sign with curly braces containing rate.toFixed, passing in 4, followed by a $sign and curly braces containing target currency. This might feel a bit overwhelming as a beginner right now, but it becomes considerably easier once you fully understand the mechanics behind it. Once again, we're relying on template literals here. There's no need to feel confused by these backticks or $signs, since we already covered template literals thoroughly earlier. Here, we referenced base currency directly. Suppose our base currency happens to be USD, for example, and the target currency is PKR, and our resulting rate comes out to something like 284.56789. What toFixed accomplishes here is that, since we passed in 4, it restricts the output to exactly 4 decimal places. So even though our raw rate came out as 284.56789, toFixed rounds it down cleanly to 4 decimal places, giving us 284.5679. This ensures the value displays properly and cleanly on the web page. After this, we move toward our catch block, completing our try and catch structure. Within the catch block, we first log using console.error rather than console.log, since this specifically represents an error, passing in the message error during recalculation as a string. We write this as a plain string followed by a comma outside the quotes, and then the error variable itself. After this below, we update result display.text content. Whatever result we'd normally display gets replaced here with an appropriate error message, since our data failed to fetch properly. And then below this, we set rateText.text content equal to unable to fetch live rates within quotes. Following this, our next task involves wiring up the swap button. But before that, let's verify this current implementation actually works correctly. So below, we already have our setup custom dropdown calls, one handling the source dropdown and the other handling the target dropdown. Within these, we'll now add calculate conversion as well. Just as setup custom dropdown currently takes source dropdown as an argument, we'll add a comma right after it, followed by calculate conversion. And similarly, within our setup custom dropdown call for target dropdown, we'll add a comma after it, followed by calculate conversion as well. The purpose here is that whenever either dropdown selected value changes, it automatically re-triggers calculate conversion, ensuring we always get fresh, real-time data. This clears out stale data and replaces it with updated results, preventing any inconsistencies. Similarly, we'll do one more thing here, referencing amount input. Let me explain its purpose as well. We call amount input.addEventListener, applying the input event this time rather than click. We call amount input.addEventListener, applying the input event this time rather than click. We write input in quotes followed by a comma outside the quotes, and then calculate conversion afterward. This essentially means that, for example, in our browser, 100 appears as the default value. If we simply clicked on it, applying a click listener instead, calculate conversion would technically still fire. But clicking alone doesn't actually change our underlying value. We're using input instead. Input specifically triggers whenever we actually type something, only then does our value genuinely update. Whether we increase, decrease, or manually type a new value, calculate conversion fires accordingly, keeping everything synchronized, which is exactly its purpose here. After this, we call calculate conversion directly below to trigger it initially. We simply write calculate conversion followed by parentheses. Now let's refresh the browser and take a look. Upon refreshing, our input defaults to 100. By default, USend shows US dollars, with INR selected below it. So initially, 100 US dollars converts to roughly 9,520.1054. And below, our accompanying text reads, 1 US dollar equals 95.2011 Indian rupees. Now, for instance, if I switch Indian rupees, over to Canadian dollar instead, you'll see that our $100 now converts to roughly 140 Canadian dollars. If I change that value from 100 down to 10, we get 40 Canadian dollars instead. So everything's functioning properly here. However, clicking the swap button currently does nothing. That's simply because we haven't implemented the swap button's logic just yet. Let's go ahead and write that logic now. To begin, we'll create a function, naming it swap currencies. Inside this function, we reference swap btn, and we apply its class list property, followed by toggle, passing in rotate as a string. Class list is a DOM-related concept we've covered previously, and toggle either adds or removes a specified class depending on its current state. If you check the style.css file and scroll down, you'll find our swap btn class alongside a rotate class. This works in such a way that whenever that rotate class gets applied, the element visually rotates 180 degrees. We've applied a transform property here, specifically rotating it 180 degrees. It rotates fully around, and Toggle simply adds or removes that rotation effect each time you click it. Below this, we declare a variable named FromItem, setting it equal to from dropdown, applying query selector on it, searching specifically for an element with both the li tag and the selected class. And similarly, we declare another variable named toItem, applying the same query selector approach onto dropdown, searching for li.selected in string format for both of these. As covered earlier, query selector can target elements by class, by ID, or simply grab the first matching child element within a parent. Similarly, we declare another variable, const_from_value, referencing our earlier FromItem variable, applying its dataset.value property. And likewise, for the second one, toItem, we declare const_to_value equal to, referencing that same toItem variable, followed by dataset.value. Now we're successfully reading both of these values, and following this we declare a const new from target variable, setting it equal to from dropdown.querySelector. Within query selector, we'll rely on template literals again, writing li followed by square brackets containing data value equal to, then within double quotes, a $sign and curly braces containing toValue. Similarly, we'll duplicate this entire line, renaming new from target to new to target instead, and we'll swap from dropdown for to dropdown accordingly. The query selector logic itself stays exactly the same. Along with the li data value template literal structure, we'll simply update the value inside the $sign and curly braces, replacing toValue with FromValue instead. Now let's understand what this actually accomplishes. Before the swap happens, for example, uSend currently shows US dollars while theyGet shows Indian rupees. Indian rupees. New from target refers specifically to whatever currency is currently selected within the TAU dropdown, in this case, INR. And new TAU target refers to whatever currency is currently selected within the from dropdown, which happens to be USD. I hope that makes sense now. Right after this below, we call update dropdown selection, passing in from dropdown and new from target. And following that, we call update dropdown selection again, this time passing into dropdown and new to target. And below, we call calculate conversion once more, ensuring this function runs again from within swap btn, updating the values accordingly. Below our amount input.add event listener call, we add swap btn.add event listener. Here we apply a click listener, since clicking triggers this specific interaction, writing click in quotes. Then, outside the quotes, a comma, followed by the function we want to call here. That function is swap currencies. Whenever clicked, this swap currencies function should execute. That's essentially the intent here. Now let's refresh the browser outside. By default, we have 10 US dollars converting to 952 Indian rupees. So first, when we click swap btn, notice how smoothly it transitions, rotating cleanly into place. Now INR appears on top, with USD shown below it. Once again, when I swap back, the corresponding value updates accordingly. Everything's working dynamically here if I switch INR over to PKR instead, and change 10 down to just 1 US dollar converts to roughly 276 Pakistani rupees. Now, clicking swap btn again, you can see the currency's swap positions instantly, and the corresponding value below updates accordingly as well. So, as you can see, we've successfully built a fully functional currency conversion application for practicing JavaScript. I hope this all made sense to you. I also mentioned earlier that I'd explain what maximum fraction digits and minimum fraction digits actually control. So, by default, our minimum fraction digits is set to 2, while maximum fraction digits is set to 4. Right now, we have 1 USD converting to INR. Let's set USD to 100. So, for example, let's replace the minimum value of 2 with 1 instead. Watch what happens. Previously with 2, we got 520.1054 as our result. Now, with it set to 1, the value stays essentially the same, but we'll keep it set to 2 going forward. This represents the minimum decimal precision. Now let's adjust the maximum, replacing 4. With 3, but before doing that, notice what appears after the decimal point currently. It shows 1054. If I now replace 4 with 3 instead, watch closely. Now we get 105 showing up. Previously it displayed 4 digits, now it's trimmed down to 3. That's essentially how this behaves. You're welcome to deploy this project using Netlify, or alternatively through Versal. So I hope you've thoroughly enjoyed and understood this JavaScript course, and if you feel there are areas where this course could improve, or if you have questions or suggestions, please feel free to share them in the comments so I can continue refining it. And secondly, which topic should I cover in the next course? Should it be React or perhaps GSAP? Let me know your thoughts. And if there's a specific topic within JavaScript that we might have missed, feel free to mention that in the comments as well. And don't forget to subscribe if you enjoyed this video so you stay updated on future courses, along with liking and sharing it with others. Thank you for watching, and I'll see you in the next video.